To kick off our course, we're going to talk a little bit about its contents and its objectives. So the course covers Spring Security. If you're not familiar with Spring Security, it is a Spring-based framework that provides us with a flexible approach to securing our Java web applications. Primarily, the framework provides two main features: authentication and authorization. You may be asking, why would I choose Spring Security? Spring Security provides a proven framework for securing our applications. It has been around since 2008, so it's been in use for roughly 7 years, and there was actually a version of this framework that preceded 2008 that started in 2003. We're really looking at something that's been around for 12 years and has been used to secure Java web applications. The nice thing about the framework is it looks at security as a cross-cutting concern. So it's very unobtrusive within your application code. You really provide a configuration and then insert the security configuration at different points within your application that does not interfere with your application's logic. So let's talk a little bit more about why people choose Spring Security. Personally, for me as a developer, I get a lot of satisfaction from building out application features. I like providing new capabilities in my applications. So maybe that's something like integrating with a social media site or providing some new efficient feature that the users are going to enjoy that's going to draw in a larger user base. So my focus is very centric to delivering capabilities. I am not as enthralled with the idea of keeping people out of the application. It's just not how I think as a developer. I'm more of a builder than a protector. The great thing about Spring Security for me is that it puts in place a proven approach that does not require a ton of time to implement. So I can focus on developing out the application features while knowing that I have put a secure layer in place to protect my application. And this leads into our next bullet point. Security continues to demand more and more time from developers. These attacks are getting more and more publicity, and therefore they attract more and more attention from your senior management, and what interests your boss should interest you, so application security becomes your concern. And Spring Security helps contain some of that impact to your priorities and allows you to focus on security while also building out good application business logic. The nice thing about Spring Security too is that it follows a consistent architecture. So if you have implemented Spring Security in one application, you can easily put it in place in another. And if everybody on your team is working under that Spring Security paradigm, they can transparently move across applications and understand the underlying security code. One final reason to choose Spring Security is, quite frankly, the number of attacks that we are seeing these days. I may prefer to develop application capabilities, but there is no ignoring application security. One thing that I look at quite frequently to keep that in mind is the Norse attack map. This is actually showing all of the different attacks occurring right now that are being tracked. And as you can see, there's quite a bit of volume. You can see a lot of the attacks are coming in, especially for the US organizations. And these are attacks against the applications that you develop. So it's very important that we take security seriously and we do a very quality job of implementing our application security. And Spring Security is there to help you with that. So let's talk a little bit about what this course covers. We're going to give you an introduction to the Spring Security framework, and we're going to go over the basics that you will need to understand in order to start implementing the framework. We're going to then take a heavy look at authentication using various approaches. So Spring Security is incredibly flexible. It supports a multitude of authentication approaches. So we're going to look at authenticating with an LDAP, an in-memory data store, and with a database. So we're going to see several flavors of authentication. We're going to move on to look at authorization. So how do we protect the resources within our application? And the great thing about Spring Security is you can make the authorization decision at multiple layers, anywhere from the UI to your controller layer to actually using access control for really fine-grained security at the domain object layer. So we're going to take a look at how we determine whether or not a user or a principal within an application is allowed to access a particular resource. And throughout the course, we're also going to take a look at the Spring Security JSP tag library. This is a tag library provided by the folks at Spring that allows you to integrate security mechanisms into your view layer. Before we conclude our course introduction, we should talk about the prerequisites for the course. First, you should have a good understanding of Java, JSP, XML, and HTML. Also, familiarity with Spring Core is necessary to complete this course. So the material in this course is not an expert level course. We're looking more at the novice to intermediate level folks that are looking to learn how to put a good security layer in place for their application. This course and this material is very timely given the current environment that application developers are working in. It, quite frankly, is a little concerning when you see the amount of attacks out there, but using Spring Security, you're going to realize it's very easy to patch up some of the vulnerabilities that people leave exposed because they're out there reinventing the wheel and writing their own security implementations that aren't as proven or as tested as something like Spring Security. And at the same time, they're wasting a lot of time and effort to put those lower quality implementations in place when they could be focusing more on developing capabilities for their end users. The lessons in this chapter will lay the foundation for us to begin working on the more technical lessons that show the real detailed view of Spring Security. We have several objectives for this chapter. First, we're going to take a look at Spring Security from a high level and just try to understand what the framework does for us. We'll take a look at some security principles that really underlie the entire framework. Next, we'll move into setting up our environment. So when we work with Spring Security, we have some tools available to us, the main one being Spring Tool Suite. And this is an IDE that's Eclipse-based, and it's going to provide us with a lot of features that really facilitate and accelerate the development of a Spring application that is secured by Spring Security. Once we have STS or Spring Tool Suite set up, we're going to configure our environment. And we'll also look at some configuration changes that can make working with the tool much more enjoyable. As part of our environment configuration, we will also set up the course project. The course project is kind of a fun one. It's all about an auto service center. We will have an application where individuals can schedule service for their automobiles, and we're going to apply security principles to it. As you work through the lessons, you'll know how to import the different projects into STS for each lesson. Finally, we're going to take a look at Spring Security in action via a demonstration. What it's going to do is really show you the concepts and the approach that underlies the Spring Security framework. I'm very excited to get started with this chapter, so let's move into our lessons. So let's start out by taking a high-level look at Spring Security and discussing its motivations and features that it offers to developers. Looking at the motivation behind the framework, Spring Security was really meant to provide a portable mechanism of providing security for a Java application. Prior to Spring Security, many individuals would use Java authentication and authorization services, or the Java EE security package, and they're all provided underneath the Java EE servlet specification. Now, here is the issue with those approaches. You are not able to make your security portable at that ear level. So within Spring Security, you have all of your security code sitting within your application, within that WAR or within that ear file. Now, when we talk about the more standardized approaches in Java EE, we're talking about security implementations or mechanisms that are reliant upon the underlying container. So something like WebLogic or Tomcat is actually going to have the implementation of that security provider. This creates an issue because when you attempt to migrate between an environment, under the standardized approaches, you are then reconfiguring your application and there's some additional setup costs. However, with Spring Security, everything is contained within your application and it's portable right along with the application. So there is less configuration and more portability. Now, it's not just about portability. There's also a bunch of features within Spring Security that outshine those that we see in the Java EE standard. And they really make our jobs as developers much easier when it comes to security. The foundation of any security mechanism or security provider is going to be authentication and authorization. We're just going to briefly cover these in this high-level overview. And when we talk about authentication, we're talking about making sure a user or a principal is who they say they are. It's important that we establish that user's identity because we're going to make decisions based upon that identity. Within Spring MVC, what you'll see is that there is really great authentication with different third-party and standard-based providers for authentication. So you'll see that you can integrate with basic HTTP authentication, you can set up your own form-based authentication, you can connect to an LDAP, you can use OpenID, or you can use X509 certificates. Spring MVC will provide that integration between your security mechanism and those authentication mechanisms. Now that we know who this individual is, what can they do within our system? What methods can they invoke? What records do they have access to? Spring Security can help us make those decisions. That's built into the framework. Now, let's say that the standards that come with Spring Security or the third-party integration are not enough. Then we are able to extend the framework with our own customizable authentication and authorization mechanisms. So we have these two basic questions. Who is our user and what can they do? What Spring Security is so great about is allowing you to expand the answers to those questions to the different layers of your application. Depending upon who is using the application and what they are allowed to do, we can then protect different areas of the application. For instance, we can restrict a user to specific URLs based upon their access within the application. So if they are trying to hit a particular web page, we can say, based upon this URL, I want to allow or deny a specific user access depending upon what authorizations they have in the application. And we can also do this at the method level. So if they hit a particular URL, that goes to a controller, and that's going to invoke a particular method, we can do things like annotate that method, and depending upon who that user is and what their permissions are, we may or may not allow them to actually invoke that method. And then we can go even more granular and really restrict access to specific entities or domain objects. So really here we're looking at that record level. We're going to establish an access control list to determine if a user can actually view a particular record. So here you'd see something like, I'm logged in as myself, I will see the records that are relevant to my account, but not those that are relevant to yours. And that's through access control and restricting the access to that information. So, authentication and authorization are very important, but there are these different attack vectors out there that attackers use to basically circumvent authentication and authorization or possibly fool it. Spring provides us protection from these out of the box. So, things like cross site request forgery are going to be prevented, cross site scripting will be prevented, clickjacking, session fixation are all going to be addressed by the Spring Security Framework. It's also going to provide us with the ability to hash and salt our passwords. So we get these other security features along with the framework that don't deal directly with authentication and authorization. So finally, we come to the question, why Spring Security? Why not something else? What does Spring Security do well that makes me want to use it? Spring Security provides a very declarative, non-intrusive approach to addressing security. Security is a cross-cutting concern, and it's best that we don't mix security logic in with our business logic. So using Spring Security, we can use annotations to address the security concerns of our application and really not pollute our underlying business logic. Another thing that's great about Spring Security is that it's part of the Spring framework. So you get a lot of the great benefits of Spring, such as dependency injection, and if you're familiar with Spring, the approach will come very natural to you, especially if you're familiar with Spring MVC, because there's a lot of great integration between Spring Security and Spring MVC. Also, Spring Security provides great testing support, so you're able to run tests as particular users, and that provides you with a new dynamic to make sure you're hitting all of your use cases. Consistency is another benefit of Spring Security. What you will see is that globally you're going to configure this security mechanism, but then the approach that is applied at the different layers of the application is very consistent. So there's not a lot of surprises when working with this framework. Before we take a deeper look at the Spring Security Framework, we're going to take a close look at some security principles that can be found within Spring Security and many other security frameworks. These are the underlying principles that really shape how we talk about security within applications. So the two big principles within application security are authentication and authorization. Authentication is making sure an individual is who they say they are. So we need to confirm the identity of the user or the person that we're looking to grant access to a specific resource. And we have multiple ways of doing this. The most common is a username and password. There's also physical tokens and pins. And then we can also use biometrics, so something like a fingerprint reader, possibly an iris scanner. Those are ways we can make sure that the user or the person that we're working with, our principal, is exactly who we think they are, and then we can make decisions about their access to specific resources. And when we make that decision about granting them access to a resource, then we move into authorization. So we can, within an application, grant somebody access to files, to a particular record, to a specific database. So there's all these different resources, and we use information that we have about the principal to make the determination whether they can access these resources. In order to reinforce this concept of authentication and authorization, we're going to step outside the confines of IT to discuss a real life application and kind of a physical application of authentication and authorization. A really good example for this is purchasing alcohol, believe it or not. In the United States, you must be 21 years old to purchase alcohol. In order to actually make that purchase, you need to provide an ID that shows that you are of age to make that purchase. So on the ID, there's going to be a photo. There will also be a description of the individual, such as their eye color, their weight, their height. And what happens during an alcohol purchase the authentication takes place first. The individual that gave them this ID and says, hey, this is my ID and this is the information about me, they're going to make sure it's the same individual. And the way they do that is by consulting the picture and making sure that the likeness in that picture matches the individual standing in front of them. And then they're also going to look at the height, the weight, and the eye color and make sure they match the individual that they see in front of them. So they are really validating that the person that just handed these credentials to them and is saying that, this is me and this is my information is being truthful, and that validation occurs to ensure nothing is going on as far as a mismatch between the individual, or what we could consider our principal, and the credentials that were provided. So this would be similar to using a username and password, but instead of a username and password, we're just using that picture and the information about the individual to say this is a match. Now, after a match is confirmed and we can be sure that the information on this ID belongs to the person in front of us, then we can begin to apply access control roles. And the access control role in this case is making sure that the individual is greater than 21 years old. So here, if we look at our date of birth, we see that the individual is greater than 21 years of age, and we are going to grant them access to this resource. So here we are performing authorization. So you see it's kind of that two-part process, and this is something very simple, but if you keep this example in mind, it will really help you understand and have a real simple, plain example when applying this concept to application security. So of course, there are always unauthorized attempts to gain access to a particular resource. So here, when we look at this scenario, we see our purchaser on the left side, and then we see the credentials or the ID that they present. You can tell right off the bat there's a problem, because the individual on the ID, that driver's license, does not match the individual that we see in the left, or a principal. So we have a problem with the credentials that have been presented. They do not match. There we see the triangle head versus the circle head, and we know, hey, you have really failed to authenticate because you cannot validate that you are the individual on this ID. So there's an example of a failure for authentication. Now, what else can happen is an individual can have an ID. So here we see they would authenticate because the photos match. But now when we begin to apply our access control rules, we see that this individual is not 21 years old. Therefore, we would not grant them access to this resource. So here we have a failure of authentication. Once again, just a simple way to look at authentication and authorization from a more concrete angle. You'll see a lot of other real-life examples. So you have an ATM card, so a debit card, that is going to have a PIN associated with it. So there are your credentials, and then you're going to have access control rules in place. Do you have the amount of money in your account that you're asking for? Email, once again, we have username and password. Once you do log into an email system, you're not granted access to every email in the system. It's matched to your ID, and that's really a form of authorization because you're only accessing emails that you're authorized. And then let's think about air travel. You schedule your flight weeks in advance. They're doing some authorization up front to make sure you can actually get on the plane. Then you get to the airport. They're checking your ID, so they're checking your authentication to make sure you are who you say you are. You board in a specific order. So there's different authorization checks that occur there too. At your workplace, you may enter a building with a token, so like a smart card and a PIN on that. You may access your computer in that way. And you'll see the same thing at fitness facilities. So I go to my gym, I scan a token, basically a key card, and then it shows my picture. They can validate that I am the individual that owns that card, and it's not somebody else using my membership card to enter the facility. So they're doing some authentication. They're also probably running checks there to make sure my account is in good standing. So there is some access control there as well. There's all these real life examples around us that allow us to just think about these security principles in really concrete terms. That way, when we're working with an application security, we have something to relate to. In this lesson, we are going to download and install the software that we will need for the course. Open up a browser and go to Google and type in Spring Tool Suite. Click the first link you see. You're going to scroll down and you'll see there's the option to download version 3.7.0, and that's the latest version. It's based upon Eclipse Mars. STS is actually a customized version of Eclipse that the folks at Spring have created in order to facilitate the development of Spring applications. So this makes it a great tool for building security into an application with Spring Security. You'll notice there is the download link, and below that is the See All Versions link. And I normally go into this page and then make sure that I am getting the proper version for my system. So for example, I'm working on a Windows machine and it's 64-bit. So I can simply click on that zip link and it's going to prompt me to download this zip file, 412 megabytes. Now I've already downloaded it. You'll want to click OK and put it in a place where you can easily locate it. I would recommend your desktop. Here we see the Spring Tool Suite zip file for version 3.7. And I'm simply just going to use my extraction program. Once that has finished extracting, we will then be able to open the software. We see the extraction has completed, and I'm just going to open that directory, and you'll notice within there is the STS bundle, and you'll see the legal folder. We're not going to go over that. There's also the Pivotal TC server. Pivotal is Spring's parent company, and TC is talking about Tomcat. So this is a customized version of the Tomcat server that they package with STS. So STS is Spring Tool Suite. We're going to go into this directory, and here you see sts.exe. And you're going to notice this looks very much like an Eclipse installation, because really it is Eclipse underlying this whole IDE that we're going to be using. Open STS, and there you'll see the splash page. It should prompt you to pick your workspace. A workspace is where you keep all of your projects. If you're not familiar with Eclipse, I would recommend just putting your workspace on your desktop so it's very easy to access. So I'm just going to click on Browse, and I'm going to go up to my desktop, and then I'm going to make a new folder, and I'm just going to call it STS Workspace, and we'll select that, hit OK. And then you'll want to be sure to check this default option. That way we don't have to go through this prompt and this configuration every time we open the IDE. And we can confirm that our installation has been successful. We'll take a closer look at the tool as we work through all of our lessons in the course. In this lesson, I'm going to show you a few STS configuration changes that will facilitate the use of Spring Security. For the first change, we're going to take a look at the Servers tab in the bottom left-hand side of the editor. This is the Pivotal TC server, or our Tomcat server, where we're going to be running our web application that we will secure throughout the course. Click on the server and right-click and then hit Start. You may encounter an error. This error is caused by having a space in the fully qualified path where you have installed STS. So I'm going to show you how to fix this issue. We'll actually need to close STS because that server's hung at the moment, and we'll open it back up, and then I'll show you the fix. Double-click on the server in the Servers tab, and this will open up a new editor tab. And we're going to click on the Open Launch Configuration link. And from here, we're going to navigate to the Arguments tab. Scroll down to the end of your configuration. And we just need to surround that value in quotes. And then if you're on Windows, you will need to change every / to a \. Hopefully, in the future, this will not be an issue for you. Once that is placed, click on Apply and then hit OK. And now we can go back and start our server. And let's make sure that it is successful at this point. Here it's going to ask us to allow the server to connect to networks. We're going to grant access. We see that our server has successfully started. Now we can run a web application on the server, and we're going to work to secure that with Spring Security. When we run web applications, we're viewing them in a browser. On the menu item named Window, click there, and then scroll down to Web Browser, and then click on Firefox. That's going to have STS use Firefox as your default browser. With that in place, the next thing I'd like to show you is to configure your Spring perspective. So we know in Eclipse there's perspectives, and that's basically the layout of the windows within the tool. I normally don't use the outline. I also don't use the Spring Explorer. And when we close those two, our editor becomes larger, which is exactly what I'm after. Close our server tab there. And here we have this dashboard tab. I really don't use this very often, so in order to make that go away, we can click on Window, go to Preferences, and then just type Dashboard. And here you can click on the News Feed Updates and disable that checkbox, and then hit OK. Then just close your dashboard, and you should no longer see that when you start up STS. The final thing I'm going to show you is how to import preferences from another instance of Eclipse or STS into this instance. And this can be very helpful because if you're like me, I'm very shortcut oriented. Most people tend to gravitate that way as they continue to work with the tool. If you are using shortcuts heavily, you may want to first go to your instance of Eclipse that has all of your shortcuts and your customizations. Go to File, Export, and then just type Preferences. Double-click on Preferences, and just make sure Export All is checked. And here you'll see it's going to kick out your JREs, your code style preferences, your compiler preferences, also your key bindings. And once we have that selected, we just click on Browse, and now we're going to say where we want to put those preferences. I'm just going to call it prefs2 for my file name, and I'm going to place it on my desktop. Once we've specified the location of the file we want to create, we just hit Finish, and I must already have a prefs2, so we'll overwrite it. If we look at the desktop, there you see prefs2. Now I have exported my preferences from another instance of Eclipse, and I'm storing that in prefs.epf. So what I'm going to show you now is how to pull those preferences into STS so that you can have all your favorite keystrokes and key bindings, as well as your JREs, available for you. So just go to File, Import, type Preferences, double-click on Preferences, and now hit Browse. And now you just navigate to that Preferences file, prefs.epf for me. And there you'll see it's going to pull in the JREs, my code style preferences, my key preferences. I hit Finish, and now I should have all of my preferences available to me. In this lesson, we just took a look at some customizations we can make to STS that will help us during our development and will also help you follow along in the course because our editors are going to be very similar. Throughout the course, we will be applying Spring security concepts to a Spring web application. In this lesson, we're going to import that web application project and configure it within STS. To begin that configuration, we need to click on the File option within the menu, scroll down to Import. Within the Import dialog, Existing Projects into Workspace option, click Next. From the Import Projects dialog, we need to browse to find the project we'd like to import. Select the Project Setup directory from our Working Files directory. Once you have selected that directory, click OK. Click Finish on this dialog, and this will cause Eclipse to import our web application project into the STS IDE. Now, you'll notice that the workspace begins to build and validate. While that's occurring, we can make one configuration change to the project that is necessary for it to run properly. Click on the project within the Package Explorer, and then hold down the Alt key and press Enter. And this will pull up the Project Properties dialog. And from this dialog, we can make configuration changes to the build path. You'll notice that we have an unbound server within this configuration. What that's saying is we need to have the implementation of the servlet specification available on our class path, or else we're going to receive errors within our project. Currently, we cannot find that server library. So what you'll need to do is click on Add Library, and then click on Server Runtime, and then click on Pivotal TC Server Developer Edition Runtime, and then simply hit Finish. And now with that new runtime in place, let's click on the unbounded server, and we'll just remove that from our class path, and then simply hit OK. And this will configure our Java build path, and now we should see some of those issues be removed from our project. So if we right-click on this Views package, and we tell STS to validate, you'll see that all of the errors disappeared. We can collapse our project, and at this point we're simply going to start the project on the server. So if you now right-click on the project and then go to Run As, you can then click on Run on Server. A great shortcut to remember here is holding Alt, Shift, and X, and then pressing R. You'll see me use this throughout the course to kick off the application. It's going to ask us which server we'd like to run the application on. So there I'm going to hit Finish. You'll see within our console that Spring is starting the web application. Once it has started the server, our browser will now pop up, and here's the application we're going to secure. This is one I've had a little bit of fun with. We're going to have some areas of this project that we want everybody to see, some that we only want a particular user type to see, another that we only want other user types to see. So the first thing, like here we have this welcome page. Well, I don't care who sees that. And if we go into our basic services page that just lists what we can do, we want everybody to see this. They're our customers. When we get into this appointments page, here it's listing out every appointment somebody has scheduled within our auto service center. This is something that really should be protected. Should I be able to see John Doe's appointment? And should he be able to come in and see mine? Should a third party be able to come in and see everybody's appointments? This is an area where we really need to add some security. As well as we have this ability to create an appointment. Should anybody be allowed to do that? Shouldn't we have to authenticate the individual making that appointment and link that to their account? So there is definitely some security holes there. Even bigger security holes exist when we drill down into an appointment. So here we see that I have an appointment for my Subaru Impreza, and I'm looking to get the oil change and the tire change, and there's the date of that appointment. If we scroll down, you'll notice these options, so we can go back, that's not a problem. We can cancel the appointment. Should somebody else be able to come in and cancel my appointment, the appointment can be confirmed. Well, that should only be by an employee from the auto service center. So should we allow a third party to see that option or to click it? And then here, there's the option to say, hey, we've completed this service, let's initiate the billing. Well, that should also be reserved for the individuals that work at the auto service center. We have a bunch of resources, and we have to decide which principals really get access to these resources. We also need to be able to make sure that the individuals logging in authenticate who they are, so we can determine if they have access to those resources by applying some sort of access control. This is a basic overview of the project. It will change some as we work through the course, and we need to introduce some different situations. So what I would really encourage you to do, as we move through each lesson, pull in the new working files for the project and set them up if you're going to work through each lesson hands-on. This will ensure that you have the latest version of the project and that you can successfully work through the lesson. In this lesson, we're going to get our first glimpse of Spring Security in action. We're going to work with a version of the course's project that has been modified to use Spring Security to protect our web application. This project uses a very minimal configuration of Spring Security, the basic building blocks that underlie the framework. We're going to start out by taking a look at the application. So I'm just going to hold Alt, Shift, and hit X, and then hit R again. And remember, that's our shortcut for run on server. And I'll just hit finish. And this is going to launch the application on the Tomcat server. You'll notice it's a little bit different than before because now we're prompted with this login page. And actually this page is generated by Spring Security. Here we just need to provide some credentials to authenticate. So I'm going to use the username user and the password password. And that's going to allow me to log into our web application. At the moment, every resource or every request is going to be scrutinized to ensure that the principal is an authenticated user. Once we've authenticated, we can then hit every other area or every other resource within the web application. But in order to make that initial request, we need to then authenticate and we can move about the app. We can refine that security configuration even further to protect some resources, not protect others, to allow some folks into certain resources while others cannot access them. So let's take a look at what it took to put that in place. It all starts with your web.xml file. And within the web.xml file, we specify a simple servlet filter. And the servlet filter is provided by Spring. It's the delegating filter proxy. And we set up the filter mapping to inspect every request coming into the application. You could configure this differently if you would like, but right now I have it set up so the filter receives every request, and then it does some processing on these requests to determine whether they need to be secured. How does it determine the logic for that processing? It's a great question we need to ask. We use the application context.xml file and place security configuration within it. So let's navigate over to that application context.xml file. We have included the Spring Security namespace. We have placed that within our configuration file, and that allows us to use the different elements within that XML configuration. And the important one here is this security:/HTTP tag. And this is basically saying that we're going to be protecting some of the requests coming into this web application. We've set it up for auto configuration, and that's where you get that default login page that it drew for us. Now there's some other default configuration that happens there. We won't go into that right now. The next line's very important. Here, we're using ANT pattern matching to protect every URL that begins with a /, so pretty much everything. And what we're saying with that access attribute is that we only want to allow users that have the authority of role_user. We only want to allow them access to basically the entire web application, which we could consider a resource here. So what we're setting up here really is an access control role. And that ties into authorization. Well, before we apply those access control roles, we need to make sure the individual is who they say they are. Where this comes into place is in Spring Security's Authentication Manager. This tells us how to check out the principals and their credentials to make sure that we have a valid user on our hands. And we do that by providing an authentication provider. We're just using a user service. That's a Spring Security term we'll talk about. Here we have our entire list of users, and it's one single user with the username of user and the password of password, and then one simple authority granted to them, which is the role_user authority. But that is enough to grant them access to our web application. We're just trying to get a glimpse of the basic building blocks of the framework. Some of the information we gather about the user here then gets applied in the other layers of the application, such as our controller or maybe access to a domain object. This has just been an overview and demonstration of Spring Security in action. We're going to work in a lot more detail, really refining these types of configurations and seeing what they're capable of. And what you're going to find in this course is that Spring Security is going to put a great architecture in place for your application where you're not writing all the plumbing code in order to authenticate and authorize your users to access resources. You're going to focus on your business logic and what's important to you, and you're going to get this consistent model of security throughout your application or any other application you develop using Spring Security. During the Spring Security Basics chapter, we're going to take a look at some of the out-of-the-box functionality of Spring Security. This is a very hands-on chapter. However, we're not going to be doing a lot of customizations to the Spring Security framework. So we're not going to be adding in, our own authentication providers or connecting to something like an LDAP. But what we are going to do is use some of the fundamental configurations in the framework to better secure our web application. And we're going to address some of the common concerns that we see when securing a web application. So let's take a look at our chapter objectives. First, we will be configuring Spring Security using XML. So we're going to be making some changes to our web.xml file, as well as establishing a Spring Bean configuration file, which will contain the majority of our Spring Security configuration. And within that configuration, we're going to use a lot of the features that you can use right out of the box with Spring Security without providing custom implementations of the different Spring Security components. So we're going to be looking at pretty basic configurations, but they really will provide a lot of rich security features to our web application. Some of the security features provided by this out-of-the-box configuration are access control. So we're going to take a look at how we can selectively grant access to resources based upon user roles and authorities. We're also going to see how we can take some of that authentication information and that information about our principal and actually make decisions about how to conditionally render content that we display to the user. Another thing that we'll take a look at during this chapter is several different types of authentication. Within Spring Security, there is the option to have the framework build out your login page and handle authentication via a DAO authentication provider. There's also the option to use HTTP Basic as a way to gather the user's credentials. And then you can also build out your own custom form and configure that within your security configuration. Finally, we will look at how we can log a user out of our web application and how that configuration takes place within our Spring Security configuration files. So this is going to be a great hands-on chapter that's really going to lay the groundwork for us to move into a more in-depth discussion of the components that make up the Spring Security framework and how we modify them in order to fit our custom application needs. In our first hands-on lesson, we will take our currently unsecure web application and apply some basic Spring Security configuration in order to secure the application. To get started with this, we need to add some dependencies to our pom.xml file. So within the Package Explorer, open the pom.xml file, and once it opens in the editor, you'll want to navigate to the Dependencies tab. And on the Dependencies tab, you will see the Add button, and this allows us to add a dependency via Maven. So the first dependency we want to add is Spring Security Web. And once we have provided that artifact ID, it will go out to the Maven repos and give us a number of options. Now, we would like the artifact with the group ID org.springframework.security. Currently, that is the official Spring dependency. So we will pull in that dependency. And now we need one more, Spring Security Config. And this is an important one because it contains the security namespace, which will provide us with some shortcuts for configuring our application. So with these changes in our pom.xml file, we want to save the file, and then we can actually go ahead and close it. The next changes that we will need to make are in our web.xml file. So we're going to go to source, main, web app, webinf, and then web.xml. Open the web.xml file. I'm actually going to maximize so we can see it better. Within this file, we need to put in place a filter. This filter needs to have a name, just like any other servlet filter, but we got to be careful about what we name this filter. This filter must be named Spring Security Filter Chain. And the reason we have to be so careful about what we name this filter is because this filter name must match a bean that is internal to Spring Security. And the next thing we specify for this filter is the filter class. And that's where this bean is important because we're going to use an org.springframework.web.filter.delegating-filter-proxy. The delegating filter proxy actually looks at that bean that's internal to Spring, the Spring Security Filter Chain bean. Within that bean is a number of other filters, and we're going to subject all of the requests coming into our web application to that chain of filters. So what this does is it really ties Spring Security Framework to that configuration of Spring Security and to that Spring Security Filter Chain bean. As with any servlet filter, we need to have a filter mapping. So this is all of the URLs that this filter will apply to. So we specify the filter name and be very careful that they match. And then we provide a URL pattern. So basically this pattern is checked against every request. If it matches, then the filter is invoked. Now that we have our filter in place, we need to specify where our Spring Security configuration will be stored. We already have one configuration file, the application-context.xml file, and that sets up some of our data persistence and our Spring MVC configuration. And we actually could put our security right in that file, but we're going to put our security configuration into its own file. So I'm just going to add another line within that parameter value for the context config location that's fed to our context loader listener for the security-context.xml file. Since we've referenced that file, we should probably create it. So we go webint, spring, and then within this folder, we're going to create that file. To do that, hold Control and press N. This opens up the new wizard, and we're going to create a new Spring Bean configuration file. So select that file type, and then hit enter, and now it asks us for a name for the file. Of course, we're going to use securitycontext.xml. Once we do that, the file is created, and the first thing we need to do is we need to add the security namespace to this configuration file. So I'm just going to click on the namespaces tab, and then I'm going to click on security. And this provides us with those XML shortcuts because here you see we're including that namespace. Now we can reference that as the prefix of our tag, and we get all these options. And the first important option we want is the HTTP tag. This has a number of attributes that we will set. The first is auto configure. Now, normally this is not set to true, but for our basic example in this first lesson, we're going to have Spring Security put a number of defaults in place. These will unravel themselves as we work through subsequent lessons. The next thing that we'll set is the use expressions. Spring has the Spring expression language or spell, and for right now, we're going to say let's not use that. Now within the HTTP tag, we can set an intercept URL. And basically this is where we're specifying that we want to protect some resources. And the way we specify the resources we would like to protect is by applying a pattern that will be checked against every incoming request. So here we're using an ANT style pattern of /***, and that's going to basically protect every resource in our application because we're going to inspect every request, because every request will match that pattern. With that in place, then we specify the access attribute. And this basically says what sort of role or authority do you need to have in order to access those resources. We're just going to say role_user. With the HTTP tag, we set up authorization. So we said What privileges must you have to access these resources? Basically, we set up access control, which is a piece of authorization. Now we're going to set up authentication. We're going to make sure that the individual logging into the application is who they say they are. And to do that, we need to set up an authentication manager. And within the authentication manager, we specify an authentication provider. So this is the mechanism that's going to authenticate the validity of our users, that they are who they say they are, basically by using credentials. And the credentials are going to be validated by this user service. And this is an implementation of a DAO authentication provider. Basically, it is just username and password checking. But with that, we need to have users. So we need a user that has a username and a password, basically credentials, and a set of authorities within the application. So within the user service, we can set up a user. And I'm just going to give them a username of user, and then a password of password. And now we need to set their authorities. And we're going to use role_user. So you see what's happening here. Here we say we're protecting this resource. In order to access that resource, you have to have this role of user. Here we're listing out all of our users where we're saying, okay, we have this principal, they have these credentials, and we're going to grant them these authorities, which would allow them to access our application. With that in place, we're going to restart our server, and we'll head over to our browser, and we're going to attempt to access the application and see what happens. You'll notice when we do this, all of a sudden we are presented with this login form. Now, if you search through all the code, you're not going to find this form. And that's because of that auto configuration attribute we set on the HTTP tag. That caused Spring Security to auto-generate this form. So you see we got a lot of security here without really doing much. So let's put in our credentials, username and password, and now all of a sudden we have access to Kevin's Auto Service Center web application. In this lesson, we learned the basics of setting up XML configuration. We'll expand upon this kind of foundation that we've just established. Currently, our application is set up to protect every resource within the system. In order to access any resource, you must have the role_user authority. Now, this is not very common. You don't just go to a website and have to log in to view the home page. We're going to apply some configurations that allow us to customize which resources can be accessed by which principals. We're going to take a look at what we would like to protect within the application and who can access those resources. We're going to create another user, an admin. We're going to give this user another authority, a role_foo. And that's just to demonstrate that these authorities can really be anything you make up. It doesn't need to be role_user. It doesn't need to be role_admin. You can customize to grant access to a particular resource. Now, let's take a look at some things that we want to expose to everyone and some other resources that we want to protect. For example, I would not like everyone to have to log in just to see my homepage. I'm trying to drum up some business here. I want them to see the services I offer. I want only authenticated users to see their appointments and to be able to create appointments. That way I don't have folks coming in and creating false appointments. And then if we look over at our new schedule section, I only want the administrative users or management users to be able to see the employee's schedule. So we need to apply some constraints on these resources. And the way we do that is by establishing new intercept URL tags within our HTTP tag. And that will set up some protection. So first, I'm just going to duplicate the intercept URL tag. And I'm going to first grant access to all of our resources to anonymous users. Now here is the only role that you really should remember because this role_anonymous is a default for Spring. This says basically allow people who are not authenticated to view this resource. And now what we can do is we can come in and protect the appointments page. Here I am setting up Spring Security to inspect the URL with every request, and if it contains /appointments/ and then possibly anything after that, we want to restrict that access to the role_user authority. So let's restart our application and we will test out this new authority that we have put in place. I'm going to caution you to make sure that you open a new browser session when you do this. If you do not, you'll have an active login with the application and it may not perform as you expect. So simply hit the URL for the app. Now I see our home page without authenticating. Let's go to the appointments page. Wait a second, I thought we protected this. Well, here's an important lesson within the configuration of the security. When Spring sees the protection or the access control being applied to these resources via these patterns, it's going to look at the first one, and if the pattern matches and the authority matches, and it says, okay, we can grant access to this resource, it will not consult the second one. If we change the order of these two intercept URL tags, we will now get the security that we expect. So I'm going to restart the server, and now I'm going to close Firefox, open Firefox. Now I can access the home page without authenticating, but when I go to the appointments page, it's going to request that I authenticate. And now we can view the appointments page. At this point, we're going to go ahead and protect the schedule. We don't want users who can authenticate with the application, basically our customers, to be able to view the employee schedule. We want to limit this to something like a manager. Let's go back to our configuration. Now add another intercept URL tag, and we want to do this above our role anonymous access that allows access to every resource. That way we don't fall into that trap where it doesn't consult our next role. And we're just going to protect /schedule/ and we're going to restrict this to foo authority. So once again, we need to restart the app, then open our browser up. As we expected, anybody can access this home page. Now I'm going to attempt to log into the schedule, admin, and password. I view the schedule, and then you'll notice that I'm also able to access the appointments because of the way we have established our users and their authorities. We notice that the admin user also has role_user authority, therefore granting them access to the appointments page. So we can configure Spring Security to be more dynamic for how it restricts access to resources. We can allow everybody to see certain resources, certain individuals to see some resources, but we got to really pay attention to how we order the configuration of that access control within our SecurityContext.xml file, because if we were to do something like this, we have now just blown our whole security because everything is open to everyone. So we want to make sure we're careful about the order of those tags. And then we also saw that you can give a user multiple authorities. And we were introduced to this role_anonymous authority, which grants access to anyone. In this lesson, we're going to take a look at another option that we have for authentication within the Spring Security framework. Currently, our authentication is completed through a form that is generated by the Spring framework. We're going to change that to use HTTP basic authentication. So instead of Spring Security generating a form, we're going to use the browser's underlying security mechanism that is built into HTTP. This is an option you might use if you're throwing together a quick prototype or you're not really looking for a very aesthetic login screen. All you need to do is within the HTTP tag, place the HTTP basic tag inside of that tag's body and just save your configuration at that point. If you simply restart your server, you can navigate to the application, attempt to access one of the secure resources. So I'm going to click on the Appointments tab, and I'll just enter in username, password, and you see there we're getting a form for authentication that is native to the Firefox web browser. So once you've put in your username and password, just hit OK, and now the application logs you in as normal. So it's just a different approach to authentication. This one isn't as popular as the next authentication method we're going to look at, which is creating your own custom form and linking it in with the Spring Security Framework. In this lesson, we will configure our web application to use one of the most common methods of authentication within Spring MVC, and that is using your own custom form for logging in. All we need to do is to have a JSP file that will serve as our form for logging in. In our example, we have login.jsp. And if we look at our home controller, this form is displayed when we hit the /login URL. Let's configure this setup within our SecurityContext.xml file. We need to remove HTTP basic, and now we're going to use the security namespace, and we're going to use the form login tag. Now there are a number of attributes on this tag that we can set up to tweak how we use our login page for authentication. The first thing we can specify is the login page itself. And we're actually going to be using the URL here that we would like to call when we attempt to access the login page. And we're actually just going to use the default, which is /login. So that will map to our home controller, which will then display our login page. Now at this point, we are going to specify the type of request for this controller. So we're going to say that the method is equal to a GET request. So we just add a new element, which is method, to this annotation, and then we specify that it is a GET request. And that will help us distinguish between whether we are requesting to receive the login form or we are posting the login form. And that's important because the next attribute that we're going to set, the login processing URL, is the URL that will invoke our actual authentication provider and tell that authentication provider to check these credentials and to actually perform the authentication for the user. Now this also defaults to /login, and we're just going to explicitly define that configuration for our purposes of becoming more familiar with the framework. So we're now going to save our changes to the SecurityContext.xml file. We need to take a look at our form at this point, because the next two configuration parameters we're going to set correspond with the parameter that will contain our username and our password. So here you see that we have custom_username and custom_password. So those are the names of the parameters that will be sent back with the request to identify the username and the password. If we go to our form login tag, these attributes are able to be set using the username-parameter attribute and also the password parameter attribute. These will by default be set to username and password. Since we're using custom_username and custom_password, we need to define those within our configuration. We are set up with our security configuration. Now we need to make a few changes to our login form. So I'm going to copy this URL, and we will now go into the login page. And here we see that our form does not have an action or a method. So we're going to use a post, and now we need to set up the URL that we will submit our form to. And that needs to be our login processing URL that we established within our security configuration. And I'm just going to assign that to a variable within the page. And then for the action on this form, we're going to assign it to that new variable we just created, our domain name with our context root /login. And that will cause us to submit to the login processing URL, which will then attempt to authenticate the user using username and password authentication via that DAO authentication provider. So at this point, we are going to run our application. So I'm going to navigate back to the Package Explorer and then hold Shift, Alt, hit X, and then hit R. And it will bring up the Run on Server dialog. We can hit Finish, and it will deploy our application and then eventually launch a browser window with it. I'll try to navigate to Appointments. Now you'll notice we get our custom login page. This is not generated by Spring. This is something we have provided. And we'll put in username, now password. We have an issue with the CSRF token. So that's cross-site request forgery. And this is something we mentioned as a feature of Spring. So they are protecting us from cross-site request forgery, and that requires us to provide a CSRF token. So in order to do that, we need to include Spring's tag libraries for Spring Security. You can just go to Maven and look for Spring-Security taglib. And then once again, you'll pick the org.springframework.security group ID, hit OK. And once that is in place, we can go back to our login page. And now we'll need to add this taglib to the top of our JSP file. We declare it. We need to provide a URI. Once you start to provide the URI, if you just hit Control Space, you will then get some auto-completion. And you can find the www.springframework.org/security/tags URI. And that's the one you'd like to use. And then just assign it a prefix. I'm going to go with SEC. All we need to do is go down to our form and add our CSRF token. There we see CSRF input. And once we put that in place, we will now restart our server, navigate back to the browser, and we'll revisit the application and attempt to log in one more time. And we'll see this time that our security configuration will be corrected, and we'll be able to authenticate using our custom form as an authentication entry point. So user, password, and there we go. We log into the application. So in this lesson, we saw how we can configure Spring Security to use a custom login form, and that allows us to keep the theming or the style of our application even on that login page that we develop. And you'll see there are other configurations that we can put in place using a custom form login. Spring Security provides some additional features that allow us to control the behavior of our form login in certain situations. If we just simply go to the Sign In link on our menu, and we attempt to sign in to the application, you'll notice that we are redirected to our root URL. So we go to our home page basically for the application. Spring Security allows us to change that. So for example, what if every time a user logged in, we wanted to send them to their appointment section? There are some caveats to this. This configuration may not take hold when the individual comes into the schedule. So for example, if an administrator attempts to log into the application and they're navigating to the schedule, we just want to send them right to the schedule. But when we click on the sign-in link, we really don't have any destination in mind, and Spring Security takes over and just defaults to the context root for the application. So we're going to look at how we can configure some of those landing pages. We just use a few of the attributes within the form login tag. The first one is the default target URL. This allows us to say that every time somebody authenticates and logs into the application, we want to send them to this default URL. So let's say we wanted to send everybody to the appointments page. We would just provide that request mapping to the appointments page. And now if we restart our application by holding Control Alt and pressing R, and you'll probably want to restart so we log out that session, we'll see that when we log in, Let's go in as an administrator. You'll see that now we're going to navigate to the appointments section. And this would happen for a regular user also. So let's run through that scenario. Now we're signing in regular user, and we go to the appointments section. Now this configuration will not take place if we are an administrator just attempting to access the schedule. So there we click the schedule link, and you'll notice we navigate to that employee schedule. So what if we always wanted it to force the flow to the appointment section? Well, there is an attribute for that, which is the always use default target. This says no matter what resource they are requesting prior to login, always send them over to our default target, in this case, appointments. So we're just going to run this scenario. So we'll log in with the administrator who's attempting to go to the schedule. And you'll notice that Spring Security will route their flow over to the appointment section. And there we have it. Spring Security allows us to specify a URL we would like to navigate to when the wrong username and password is entered. By default, it's going to go back to the /login page. We're going to add this error parameter and indicate that it's true. What that allows us to do is within our login page, we can now add a little bit of output to the user. So we can call upon JSTL and we can test to see if that param is not null. And if it's not, we can just display some information to our user. Here, what we've done is we have refined the form login tag configuration in order to specify this authentication failure URL. Where do we go if they fail to authenticate? So the wrong username and password. And we're going to ship them back to the login.jsp page, but we now have that parameter which we can key off of in order to display an error message. So I'm just going to restart our server. We'll open the application back up. And I'm going to sign in under a user that doesn't exist. We'll give a password to Joe. And now we see that it provides us with this error message, so invalid username and password. This is just an example of some of the further refinements that we can achieve with the form login tag within that security namespace. So it really allows us to shape our login process with Spring Security. Once a user has authenticated within our application, there are a number of concerns that may change depending upon the authenticated user. We may want to make changes to our user interface since we know who the user is and we know that they're authenticated. So here I'm going to sign in as a user. We may want to change something like our sign-in link. It's no longer needed. We want to have a greeting for the user at this point and also provide them an option to log out. However, we would not want to display that sort of content to a user who is not authenticated. We're going to take a look at how we can use some of the features of Spring Security Tag library to conditionally render content to our users based upon their authentication status. We will add a bean into our SecurityContext.xml file. Now this bean will allow us to use expressions within the tags in our view. And we have to specify the bean's class. And then it is a default web security expression handler. We can then use IntelliSense to autocomplete the path. We'll switch over to our header. Here is where we would like to make our modifications. We need to conditionally display our sign-in link depending upon the authentication status of the user. To do this, we need to add the Spring Security Tag library. So once again, just hitting Control Space, accessing the IntelliSense, and then providing a prefix. And we'll go with SEC once again. We're also going to add the JSTL tag library to help us with our conditional display. For JSTL, you want to make sure you have the one that is java.sun.com/JSP/JSTL/core. So the one we're on right here. And we'll add that to our JSP file, and we'll go with the traditional prefix of C. We'll add a new line above our sign-in link. Now we're going to use one of our Spring Security tags, and that is the Authorize tag. This tag would be used to wrap content. So we would put something like this in the body of the tag, and then we use an access attribute. Within here, we can enter some for role or some for expression. In our case, we want to use the authenticated expression. And this is just a simple way to use expression language to say, make sure this individual is authenticated within the application. But instead of just having this link be conditionally displayed within the body of our authorized tag, we're going to assign the value of this tag. So it's going to be a conditional, a Boolean, true or false, whether or not they are authenticated, to a variable. And we'll just call that variable authenticated. Now that we have that variable with the authorized tag, we can then begin to use JSTL to put a conditional in place. We'll use the choose conditional, and within the choose, we'll put a when, and then we'll put an otherwise. And our test condition here will be a check against that authenticated variable that we created. If they are authenticated, we're going to be displaying our user's name and also a logout link. So we're going to create a paragraph, and the paragraph is going to have a class navbar text. This is just some bootstrap markup, so it's not part of Spring Security. And within that paragraph, say welcome, and then we are going to display the user's name, which will be their username. And then we're going to provide a link for them to log out. And now I'm simply going to wrap all of this within its own list item, and we'll indent those a little to make sure it's all lined up. So we will display a welcome message to our user that contains their name, and then we will also have a logout link that follows their name, which eventually will allow them to log out. And we need to move this line item so it will be displayed only when a user is authenticated. And now we simply move our login link into the otherwise block. So at this point, our user interface will react conditionally depending upon whether the user is authenticated. So let's restart our server, open up a new browser to log out. We'll hit the application. I will click on the sign-in link, and now let's log in as the admin. There we see up top, welcome admin. We no longer see our sign-in link, and we actually see the logout link. So we were able to achieve that by using some of the tags that are present within the Spring Security tag library. They allow us to access information about the authentication and make some conditional choices on our user interface. Logging out users is a common concern amongst all web applications. In this lesson, we're going to see how Spring Security makes logging out users very simple. To begin, we're going to look at our header.jsp file. Within that JSP file, we have added this anchor tag, which navigates to /logout. Our intent is to have this anchor tag log out the user from the application. One of the things that we're going to have to change about this header.jsp file is how the logout occurs. At the moment, if we were to click on this anchor tag within the application, it's going to fire off a request of type GET to the application server. Unfortunately, we can only log out a user via a POST request. This prevents users from having an attacker log them out via a CSRF attack. Within the list item tag, we're going to add a form, and the form is going to have a method of post, And then for the action, we're going to grab our URL that we are creating within the href. We will place that within the action. We'll give our anchor tag an href of pound. And now inside our form tag, we need to use Spring Security to put in a CSRF input tag. So at this point, our header has been set up to include a hidden form that will post to our logout URL. In order to have this form be submitted, when we click on the logout anchor, we're going to add an ID, and then we're going to write some JavaScript, which is going to use this anchor tag as well as this form tag, which will also give an ID of logout form. Now I'm going to navigate to the global.js file, which was added to every JSP in our application. From here, we are going to write some simple JavaScript. So we're going to use jQuery, and we're going to grab the logout anchor tag. Every time that anchor tag is clicked, we're going to execute a function. That function is first going to prevent the default event, so that's going to keep us from actually navigating to the pound sign, which is specified as the href. Then it's going to grab the logout form via jQuery, and then we're going to submit that form. So with this simple little piece of JavaScript, we've now allowed our anchor tag to actually perform a post via a hidden form. So let's return back to our header. You'll notice that we would like to log the user out when we post to this /logout URL. So we need to take that URL over into our SecurityContext.xml file. Within this file, we're going to configure a logout tag inside of our HTTP tag. So we're going to use the security prefix, and we're going to use the logout tag. Now the logout tag has some attributes on it that we'll use to further refine our configuration. The first is the logout URL. Essentially, this says when I receive a post to the URL we're going to specify here, invalidate their session and log them out. So that needs to be the URL that we're pointing to in that hidden form. Next, we're going to look at the logout success URL. And this is pretty similar to the authentication failure URL, except now when we log out successfully, we want to navigate to a certain page. So where do we go after I've logged somebody out? Navigate to the login page, and we're going to set a parameter named logout, and we'll set its value to true. So essentially what is going to happen is a user is going to click on the logout link in the header. That's going to kick off our JavaScript event handler, and it's going to submit our form on the header. This form calls the /logout link and passes in a CSRF token. Since we have configured that logout URL, it's going to receive that request submitted by the form. It's going to log the user out, and now it's going to send them to our login page, setting this logout parameter to true. We need to navigate to our login page. We're going to display a message to let them know they have successfully logged out. So since that logout parameter has been entered in our success URL, we can key off of that parameter to conditionally display some logic. So here we're just going to look for the log out parameter, and then we're just going to say you have successfully been logged out. Let's restart our server, head over to our browser, open the application up, and we'll log in. Now you see our logout URL, and once we click on that URL, it says you have successfully been logged out. So that's how we can use the Spring Security Framework to log out our users. This chapter focuses on the customizations that we can make to Spring Security's authentication process. We have seen all of the features that come with Spring Security out of the box, and how rapidly we can establish application security. In this chapter, we're going to peel back some of the layers of the onion to really see the internals that provide us with that functionality, and we're going to work to customize them. One of my gripes with a lot of the trainings I've attended or a lot of the reference materials that I have studied is that they provide you with great circumstances. You get this nice application, it teaches you all these basics, and then you go back to your desk, and when you have to move beyond the basics to really conform to the challenges you face in your daily environment, it's sort of lacking what you've been taught. This chapter really provides you with what you need to get your hands dirty with the framework once you enter that work environment and need to apply the authentication principles of Spring Security to your situation. So let's talk a little about what we're trying to achieve in this chapter. The first thing we're going to do is we're going to take a look at how authentication fits into Spring Security. How do we enter the authentication process? And we'll take a look at security interceptors and the role they play within the framework and how they are able to protect resources and route us into the authentication process. Once we talk about how we get to the point where we perform authentication, we're going to look at some of the main components that allow us to authenticate a user. We have these security interceptors that are high at this global level, and then we have these components that really help us with authentication. And one we're going to look at is the UserDetailsService, and this allows us to retrieve information about a particular principal that we have stored in something like a database. Next, we'll look at the SecurityContextHolder, and this is a component that allows us to retrieve information about the authenticated user pretty much anywhere within our code. The UserDetails object works closely with the UserDetailsService, but basically it is Spring Security's representation of a user within the framework. We'll learn how we can integrate a UserDetails object with a custom user object we may have for our application. We'll also take a look at how we can create new users within an application and how we can authenticate them. And that's very easy when we have implemented the UserDetails interface with our custom user object for our domain. We'll next take a look at authentication providers and how they allow us to configure authentication logic within an application. So once we need to move beyond just checking username and password, we can establish an implementation of an authentication provider, and we can pretty much use all sorts of custom logic to determine whether or not we authenticate a principal. Now, the authentication provider relies upon an authentication object. You'll see that once we enter an authenticate method on the authentication provider, it gets passed this authentication object. At that point, the authentication object really represents the user's credentials. So it's that information they are presenting to us. This is who I am, and here's how I validate it. So username and password, something like that. And then the authenticate method on the authentication provider passes back another instance of an authentication object. This instance actually has the authorities that are granted to that principal or that user. By passing back that authentication object, we are saying they have successfully authenticated. So we'll look at that process, and we'll also look at how we can create our own authentication objects and integrate them within Spring Security's authentication process. We're really going to dig into some of the internals within Spring Security, and I always enjoy getting that really down in the weeds look at things. In this lesson, we will focus on the Security Interceptor component within the Spring Security framework. The Security Interceptor is responsible for granting access to different resources within our application. There are two varieties of Security Interceptors which are meant to protect different secured resources. The first is a Filter Security Interceptor. This interceptor basically filters all requests coming in, inspects their URL, and then decides whether or not to grant access to that particular resource. The Method Security Interceptor inspects all method invocations within our execution and decides whether or not a particular principal can invoke a method. Now, all of these security interceptors are configured using config attributes. So these are simple pieces of configuration that we provide, maybe via XML or via an annotation, to the security interceptor implementation, and it uses that information to determine who should be granted access to what resources, so methods or different HTTP resources that we're serving up through the application. So these are the two primary security interceptors that you will deal with within Spring Security. You can make your own implementation of the security interceptor by extending the abstract security interceptor class. However, most of the situations you will encounter have already been handled by these two security interceptors. So let's talk about how these security interceptors find their way into our applications, which are secured by Spring Security. If you look at the top left box, there we see a snippet from our web.xml file. And we are putting in place a delegating filter proxy, and we are naming that filter Spring Security Filter Chain. If you'll remember, within our security configuration file, SecurityContextHolder, we then use the HTTP tag in order to quickly configure our application. Now, there's another tag within that security namespace, the global method security tag, and that would enable a method security interceptor. But looking closely at the HTTP tag, we don't really see an interceptor being set up there. So if we look at our lower box, we really see what's going on behind the scenes with that HTTP tag. So what happens is that a filter chain proxy is created, and it will have an ID of Spring Security Filter Chain, and that bean establishes the chain of filters that will be consulted when we access resources through the application. So when a request comes in, all of these filters are going to be checked against that URL, and we're going to decide if a particular principal has permissions to access that resource. Now, you'll see that within that filter chain, we have a filter security interceptor filter that we're pointing to, and that's defined as a bean lower within our configuration. In a nutshell, the delegating filter proxy points to a filter chain which can have many filters. Within that chain, a filter security interceptor is placed when we use the HTTP configuration tag. So we went through and used this, but we didn't talk really about the underlying details of how that configuration works. So once the filter security interceptor and the method security interceptor are in place, what happens? Well, they're going to sit and intercept every request coming in. Basically, every request will get routed to them. And for the filter security interceptor, it's really going to be protecting all the requests coming into our different controller methods. So there we see that we have our filter security interceptor, which we see in green, and we're highlighting the request mappings, which are really going to be where particular URLs will be routed within our application in our controllers. Next, you'll see in red the method security interceptor, and it's looking at that secured annotation, and that's a configuration attribute for the method security interceptor. And when it sees that secured annotation, it's going to require some sort of authorization to execute or invoke that method. We've been talking a lot mainly about access control. So how does this have to deal with authentication? Here is where the tie-in to authentication occurs. When that principal, so our user, submits a request that's going to access some resource, whether it be a method or some HTTP resource, the security interceptor stands in place. And the first question it really asks is this user authenticated? If the user is authenticated, we check their access, and based upon our authorization roles, we will grant them access or not. But if the principal has not been authenticated, then we're going to drop down into this large green bar here, Within that green bar, we see all of the components that are really important for authentication within Spring Security. So we're going to be taking a look at these individual pieces. We're going to learn how to customize them. So we're peeling back the layers of the onion, kind of getting past some of the superficial points of Spring Security and really looking at what's underneath the hood and what we can customize to fit our application. So here you'll see within that authentication umbrella that we see in the lower green bar, we're going to be working with an authentication object, and that is going to be containing the user's credentials as well as storing more information about the user once we have authenticated them. The authentication object will get passed to an authentication manager that is going to delegate to an authentication provider. And here is where our real authentication takes place. The authentication provider is going to make that determination that this user is who they say they are. Now, some authentication providers will work with a user details service, and this is basically reaching into some sort of data store, whether it be in memory, a database, an LDAP, and it pulls out information about the user. Some of that information contains their credentials that we're going to then validate with what has been provided by the user. So it depends upon the type of authentication provider whether or not we will use that user details service. Finally, once we have authenticated a user, we're going to place that authentication object or that user within the SecurityContextHolder. And this is a component that is available to us throughout our controllers that allows us to retrieve security information about the principal. We're looking at security interceptors right now from the perspective that they allow us to tie into the authentication process within Spring Security. And now we're going to begin to focus on those components that make up the authentication process. If we inspect our securitycontext.xml file, you'll notice that for our authentication provider, we are using an in-memory user service. This approach is not very dynamic because we really can't expand upon the amount of users within the system. So in this lesson, we're going to create our own custom user details service, which will be a little bit more robust. So the first thing that we'll do is we will remove the user service within our authentication provider. Now, by default, our authentication provider is a DAO authentication provider. Basically, this means that it looks at a username and a password and compares it to what is returned by the user service. So the user will enter an authentication object which contains a username and password. The authentication provider, which is the DAO authentication provider, will then pass that username off to a user service, which will then return the information for that particular user. A comparison is then made between the credentials provided by the user service and the authentication object's credentials to determine if the user is indeed valid. So we'll take out that user service, and now we can specify on our authentication provider tag a user service ref. So this should point to a bean that implements the UserDetailsService interface. Now currently we do not have that class, so we are going to create it. So within our package explorer, I'm going to go to the com.o'reilly.security package and simply hit Control-N to pull up the new dialog, and then I'll create a new class. I'm going to call my new class Custom User Details Service. I'm going to implement the User Details Service interface. So I'll pull that interface up and then simply hit OK. And now I can finish and our class will be created. So we have this one method on the User Details Service interface that we must provide an implementation for, and that's the load user by username method. So the way we're going to approach this is first we're going to make this a bean. So I will add the component annotation, and I'm going to provide a name of custom user details service, and I'll copy that. We'll import our component annotation. Since we are working with a bean, we're going to auto-wire the auto user repository so that we can query our database for auto users. So I'm going to add a private auto user repository object, and I'll just call that repo, and we'll import the auto-wired annotation. We need to perform some component scanning so that we pick up this component annotation. We will first open our pom.xml file because we need to include the context namespace to perform component scanning. So we're going to go out and we're going to look for the dependency Spring Context Support, and we'll pull in that dependency. And I'm going to make the version match all of the other Spring components I have. So it's going to be 4.1.7. I'm pulling from the org.spring framework group ID, and I'll save that, and we can now close our pom.xml file. And then this allows us to enable the namespace within our securitycontext.xml file. So there we have the context namespace. We can go in, and now we can component scan using the context namespace. And I want to scan com.o'reilly.security. And that's going to cause Spring to look for beans within that package, which means it's going to pick up our custom user detail service. This is all basic Spring core, as I mentioned before. Then it can then auto-wire the user repository. We need to first consult the repository and pull out a auto user by the username. Currently, if we look at our repository, we do not have that method, but we can easily create one because we're using Spring data. So public auto user, find by username, provide a string username, and that's going to do all that plumbing for us very quickly. So now we can use that method, we can invoke it, and pass in the username being provided by the load user by username method as a parameter. Now we have our user, we've pulled them from the database. All we need to do now is return a user details object to Spring Security. The user class within Spring implements the user details interface. So if we pull in the org.springframework.security.core.userdetails.user class, we can then create a new instance of user details. And here, what we do is we pass in the username, password, and then finally we pass in any roles into an authorityutils.createAuthority list. Now we get the user and we get their roles. And at this point, we have created our new user details object. So what Spring Security will do now, it's going to compare what the users passed in to this information that we pulled back from our database. So if the password doesn't match what the user provided, it's not going to authenticate them and allow them to access a particular resource. There's one last thing we need to do. You remember that we haven't provided our bean name yet. So we're going to copy the bean name, custom user detail service, and we'll navigate over to the securitycontext.xml file. And now we will provide our bean name for our user service ref attribute. And it's going to point to that user service that we have defined and that will become a bean via Spring's component scanning. You can look in the init SQL file, and here you see we have created a number of users, and we have stored them within our database. So I'm going to log in as Junior Doe, so JRDOE, and then the password is password. I can quickly restart my Tomcat server, and now we can navigate over to the application. We can now attempt to log in with Junior Doe's credentials, which are stored in our database and accessed via our user details service. And there you see we're able to log in with a user whose credentials are stored in our database. So this was a look at the user details service within Spring Security. In this lesson, we will be working with the Security Context Holder. The security context holder holds a security context which contains information about the currently logged in user as well as their authorities. It allows us access to the user details of that user. So there's a lot of information we can pull and use from the security context, which is stored in the security context holder. We're going to modify our appointment controller, and particularly we're going to modify the save appointment method. We have basically hard-coded an auto user when we save an appointment, and then we set that user on the appointment. We're going to make this more dynamic by relying upon our security context holder to retrieve the information about our currently authenticated user. The first thing that we're going to do is we are going to add an auto user repository. So I'm going to declare a field that has private access, and it will be of type auto user repository. And then we're going to auto wire that field. So we'll import those types. And now we have access to our auto user repository, which we can now query that auto user table in our database. Next, we're going to remove all of these invocations of these set methods. We're no longer going to be setting those values on our user. We're going to be pulling them from our database by using the information we receive about the authenticated user. We have the security context holder, and it has a static method that allows us to get the security context. Now, on this security context is a method that allows us to obtain the authentication object. You also notice we could set the authentication object, but that is really taken care of when we perform our authentication within the application. You can use it manually if necessary, though. In this case, we're just going to get the authentication object, and here is where the real goodies are. I can access the authorities. So when we talk about authorities, these are the roles that we were assigning to those users. So like role_user, role_admin. These are the types of permissions that this currently authenticated user has. We can also look at their credentials. So in this case, it'd be username and password. We can get the username, and we can also get the principal, which is normally the UserDetails object that we saw with the UserDetailsService. You can also see if the user is authenticated, and that will return a Boolean. Right now, we're just interested in retrieving the name, and this is going to return the username of our currently authenticated user. So I'm going to store that within a string. We're going to use our auto user repository, and we're going to invoke the findByUsername method, and we're going to pull that user out of the database so we have all their information. It's very powerful. It's very common to use the security context holder within a controller method to get the principal. So let's save these changes, and then we'll restart our app. And now let's log in as Junior Doe. And now we're going to create an appointment. So I'm just going to click the calendar and then select a date. And the car's make will be a Subaru. We'll say it's an XV. And we'll say it's 2015, and we just want to get the oil changed. So we're going to hit Save Changes, and you'll notice that Junior Doe's appointment gets added to our list. Now previously, that would have been the hard-coded information that we had before. This security context holder is made possible by having a security context persistence filter. So we talked about those different filters that get registered within our filter proxy chain, and the security context persistence filter is one of them. It is responsible for binding the security context to the current thread or the current web request. It performs that action by looking at the security context repository, where it stores information about the security context. So when each request comes in, it looks for the security context within the security context repository and then binds it to that web request. Now, an important thing is that this is accessible by the local thread. A request is tied to a thread, and then when we're working within our controllers, we're accessing that local thread. So that's why we can call this static method and get that security context. If we look at our custom UserDetailsService class, we'll notice that within the load user by username method, we are retrieving an auto user from our repository, so from our database, and then we take the fields on that auto user object and we use it to populate the arguments in the user constructor. Now remember that user is a class provided by Spring, and if we inspect this class, we'll see that it implements the UserDetails interface. The UserDetails interface is created by Spring to act as an abstraction for a user throughout Spring Security. So this is basically the underlying user or principal class within the framework. And we see there are some methods on that interface: get authorities, get password, get username. Is the account expired? Is it locked? And we have to provide implementations of all of those methods if we want to extend the UserDetails interface. What happens because there's this UserDetails interface and then we have our auto user class is that we find ourselves going back and forth between auto user and the UserDetails class. So within our appointment controller, here we actually have to pull out the username and then query our repository. Well, it would be a lot easier if we could just pull our actual auto user from the security context. So we're going to look at how we bridge that gap using our UserDetails service and our auto user object. We're simply going to navigate to the auto user class, and we're going to now implement the UserDetails interface, and then we'll add all of the unimplemented methods. And if we scroll down, we'll see that the first method that we must implement is the getAuthorities method. Granted authorities are really objects that represent application-wide permissions within our system. So these are going to grant a user permissions across a large number of operations. You're not going to see these granted authorities used like access control, where it's going to restrict our specific user to a certain appointment. These are more, can you access the add appointment feature within the application, something along that global scale, a little bit larger than just defining smaller access control. So we're going to return all of the authorities granted to this user. So we're going to use authority utils, and we're going to use the create authority list method. This will allow us to provide a string, so something like role_user, to this create authorities list method as an argument, and it returns us a collection of granted authorities. Now in this case, we're just going to return the role that is assigned to this user. We also need to provide some logic for the isAccountNonExpired method, as well as the isAccountNonLocked. A lot of these are really just checking to see whether or not the account is enabled. And we're just going to mock these up and put true. You may not always use these. You may have some logic to discern this information, or you may store this information in the database. But for our purposes, we're just going to return true for all these so we don't get kicked out of the application. So at this point, our auto user class implements the UserDetails interface provided by Spring. We can go to our custom UserDetails service, and now instead of taking the fields from our auto user object and placing them in the constructor for the user, we can simply return the user that we pull from the repo. So there we just return the auto user object because it implements UserDetails. And then what this allows us to do is it allows us to make our controller method more concise, because we're just going to pull out the principal here. So that UserDetails object will be stored in the principal, and we can assign that to our auto user. And we'll take out that line. And now we just need to cast to the auto user object. And at this point, we're not hitting the database, so we saved a trip. What we've done by implementing the user details interface is we've allowed ourselves to store in the security context our application's specific representation of a user, which also conforms to the Spring security expectations of a user. So let's just restart our server now, and we'll run through a demonstration, and we'll see that everything works as we expected. So I'm going to navigate to the application, and I'm going to go to the appointments section, and I'm going to be prompted to sign in. I'm going to use Junior Doe one more time, so JR Doe and password. And then I'm going to create an appointment. Let's make it on Wednesday. And we'll say this is for a Subaru, and we'll say this is for a WRX, and we'll say it's 2016, and we need the tire changed. So we were able to use our user details interface, which is implemented by our auto user class, in order to make it more seamless with the Spring Security Framework. In this lesson, we will learn how to create a new user account and how to programmatically authenticate a user using Spring's authentication object and the security context holder. So if we look at our files within our project, you'll notice that we have added a register.jsp file underneath the webinf views directory. This JSP will act as a registration form, which will allow users to create a new account within the system. You'll notice that within the form, we are posting to the /register URL using a post method. This will allow us to submit that post, and that's going to contain all of the information we need to create that user account. We're going to process that request within the home controller. Now, we have a link established to the register page within the header file. So we will be able to navigate to this form in order to create a new account. Then we will post to the home controller, where we're going to set up some controller handler methods that will then save the user account and authenticate the user. So the first thing we're going to do is within our home controller, we're going to set up a request mapping, and we're going to map to the value of /register. And we're going to use the get method for this request. Now we need to set up our method. So it's going to be a public method that returns a string, and we'll call it goRegister. Within the body of that method, we're just going to simply return a string named register. That is enough to display our registration page. Now we're going to duplicate our goRegister method, and we will change the name of the method to simply register. We're going to change the request method to a post. So this will handle when the registration form posts to the controller and posts to the /register URL. When we do this, we want to capture the information posted by the form. So we're going to add the model attribute annotation, and we're going to add a parameter of type AutoUser, and we'll name it user. With those in place, we now have the information submitted by the form. Next, we're going to hard code the role for the user to a simple user role. We're not going to give them administrative privileges. And now we need to save that new user within our database. To do that, we're going to declare a new field of type AutoUserRepository, and I'm just going to name that field repo. And then we need to auto-wire that field. We'll import our annotations by hitting Control-Shift and pressing O. Now we're going to use that repo to save our user, and they will now be saved in our database. We need to authenticate this new user. Remember, they're not going through Spring's authentication process, so we're going to programmatically authenticate them. And there is an interface that really helps us perform this, and it's the authentication interface. So we're going to create a new object with the name auth of type authentication. And then we need to provide an implementation of that interface. So we're going to use a new username and password authentication token. So we will import those types. And the first argument that we need to provide into that username password authentication token constructor is we need to provide our principal or our user details object. So we're going to pass in the auto user because it implements the user details interface. We can just pass it in as that first parameter. Next, we need to provide the credentials they logged in with. So we need to provide the password. And then we need to get their authorities. We have now built an authentication object using the username password authentication token constructor. So let's talk a little bit about the authentication object. It is first created when a user attempts to log in. It normally stores all of their credentials. And then once a user is authenticated, the authentication object is placed within the security context. And we've seen this before. It's that interface that contains the get authorities, get credentials, get details, get principal methods that we can implement if we were creating our own custom authentication object. For right now, we're just going to use one out of the box from Spring. Now, once we have the authentication object built, we can now rely upon our security context holder. We can get the security context, and now we can set the authentication. And we're simply going to pass in our authentication object. This is enough to programmatically register a user and authenticate them within the system. And then we also need to switch our destination. So instead of going back to the register page, let's actually head to the root of the application. Let's save our changes. And we're just going to restart our server. And once our server restarts, we can navigate over to the browser. And at this point, I'm going to click on the registration form. And now I'm going to create a new user. We'll use Kevin B as the username, Kevin Bowersox, kevin@gmail.com as the email, and password. Okay, so now you see it has logged in Kevin B. And if we were to log out, we can log back in because we have saved this user. And there we see our user, Kevin B, logs back in. So we were able to create a new user using the authentication object and using the security context holder. Currently, our application is using a DAO authentication provider in order to authenticate the user. A DAO authentication provider compares the provided password with the password we have on record for a particular user. When the password matches, we authenticate the user. In this lesson, we're going to build a custom authentication provider, which is going to act a little bit differently than our DAO authentication provider. In order to begin creating this custom authentication provider, we need to create a new class within our com.o'reilly.security package. So I'm going to hit Control-N to open the new dialog, and then just type class, and then we're going to name this class Custom Authentication Provider. And this class must implement the Authentication Provider interface. So once I have that interface selected, I can just hit Finish. And now we see our new Custom Authentication Provider class. You'll notice that because we have implemented the Authentication Provider interface, we have two methods that we must provide implementations for. The first is the supports method. This accepts a parameter of type class, and this is going to be the authentication class that we will support for this authentication provider. So this can be something like a username and password authentication token. And we can just inspect the class to see that it is equal to our authentication argument that's passed in. Now, there are other types of implementations of the authentication type that could be passed in here. So for example, let's say something like an X509 certificate authentication object is not going to match our username and password authentication token. So Spring Security would then know not to invoke our authenticate method in order to authenticate the user. So now we're talking about the authenticate method, and that's exactly what it does. It has the logic that will authenticate our user. If the user fails authentication, we return an authentication exception, and that will break the authentication chain. However, if the authentication is successful, we return a new implementation of the authentication object that contains the authorities granted to the user. We're going to declare a username and password authentication token. Because we know that this authentication object being passed in is of type username and password authentication token because of our supports method. So we can perform this hard cast right to that type of authentication object, and we don't have to worry about any casting problems. Now, what we'll do is we're going to auto wire in a new field that is of type auto user repository, and we'll just name that repo. We're going to use this to obtain the auto user from our database. So we're going to use the repo to reach in and find the username that corresponds with our auto user. So we pass in the username to the find by username method, and that returns us our auto user. At this point, we can then begin to inspect those credentials that we pulled from our data store with those that have been provided by our user. So we're going to use an if statement, and we're going to say if user.getPassword equals ignore case. So here's that case insensitive piece we spoke about. And we're going to check that it's equal to the credentials provided on the token that the user's logging in with. And we're going to send that to a string, and we're actually going to negate this. We're going to do a case insensitive comparison of the provided password with the password we have stored. If there is a mismatch, we are going to throw a new bad credentials exception, and we're just going to say the credentials are invalid. And this will break our authentication process and alert the user there's a problem. So what if we get past this check and we are successful? Well, at this point, we need to build that new authentication object. So we're going to once again work with the username and password authentication token. The first thing we provide is our principal or our user details object. And because the auto user implements that interface, we can simply pass it in. Next, we provide the credentials. So we're going to get the password here. And the next parameter that we provide is the authorities. So all those granted authorities to this user. So at this point, we have the implementation of our custom authentication provider. We just need to declare it as a bean, and we're going to give that bean a name of custom authentication provider, and this will get picked up via the component scanning. Now go back to our SecurityContext.xml file, and we're going to change the configuration of our authentication provider. The first thing we're going to do, remove the UserDetailsService, and now we're going to use the ref attribute to specify the bean that is our custom authentication provider. So with our custom authentication provider in place, I'm going to restart our server, and then I'm going to navigate to the application, attempt to sign in as Junior Doe. First, I'm just going to provide the wrong password to test out that case. There we see we get some information saying that we supplied the wrong username and password. So let's go with Junior Doe once again, but I'm going to use the caps lock key here to enter password in all caps. And then when I log in, you'll see that we have authenticated. And under the old DAO authentication provider, which we were using, we would not have been able to do that. But because Spring Security grants us the ability to provide a custom authentication provider which can perform whatever logic we would like in order to authenticate our users, we can now have something like a case-insensitive check against our password. Not recommended, but it's just nice to see that flexibility. When building an application, it may be necessary to take into consideration other factors than the username and password when authenticating a user. For example, if we look at our login.jsp page, you'll notice that in addition to the username and password field, we also accept this automobile make field. We're going to add this make field into a custom authentication object. And that authentication object is then going to be used by our authentication provider in order to determine whether or not we should authenticate a user. In this instance, we're going to check that a vehicle for a user is of a particular make. And if it's not, we're going to deny access to the application. It's going to provide us with a good demonstration of how to create a custom authentication object that can contain some additional credentials that we can consider when authenticating our users. To get started, the first thing we'll do is create a new class within our security package. So I'm going to use the new dialog to create a new class, Custom Authentication Token. We're also going to have this class extend the username and password authentication token. Because we are considering username and password as credentials, we're just going to extend that existing type, but we're going to add an additional field, which is the make field, and it's going to be of type string. And then we're going to add a get method for the make field. Now, with that in place, we're next going to create a new constructor for this custom authentication token. This constructor will be used when we are creating the authentication token when the user logs in. The first thing that we want to add to this constructor is the principal. We're going to make the credentials a string, and then make should also be a string. Now, there is another constructor that we'll add to this class, which is going to be used once we have authenticated the user and we now want to return an authentication object within the authentication provider. For this constructor, we're going to open the Generate Constructor dialog, and then we're going to actually use the username and password authentication token, and we're going to use the variation that accepts the collection of granted authorities. So just click OK. And you can also just type this out. But if you're familiar with Eclipse, it's a lot easier to use the Generate Constructor dialog. And you can simply right-click and then go to Source and then Generate Constructor using fields. And that will open that dialog for you. Now that we have our constructor template put in place, we're going to modify this so it accepts an auto user. For the credentials, once again, we're going to use a string. We're going to import the auto user type. So there we have our second constructor. And this class, our custom authentication token, is going to serve as our new authentication object when the user is logging into the system. We'll go ahead and we will save this class. Next, we're going to return to our Package Explorer, and we're going to create another class. And we're going to call this class the Custom Authentication Filter. And this class needs to extend the username and password authentication filter. Once we have that in place, we'll click Finish, and now we can begin to work on our new class. This is a filter, and it will be entered into the filter proxy chain, just like our username and password authentication filter is currently. We'll see that configuration in a little bit. But basically what this filter is going to do, it's going to pull the information out of the request that gets submitted so that we can build our authentication object. To do this, we're going to right-click within the editor, and we're going to go to Source, and then we're going to click on Override and Implement Methods. First, deselect all of the methods, and then we want to override the Attempt Authentication method. This method gets very close to the servlet API because we're dealing with a request and a response. So the first thing we're going to do is we're going to pull some information from the request. And we can do that using some methods within the superclass username password authentication filter. So they have a method that allows us to obtain the username for our request, and we can also obtain the password very easily. Next, we're going to obtain our make parameter, which is being passed. And to do this, we're simply going to access the parameter within the request as you would almost any other parameter within a servlet. So we'll simply specify make as the parameter we'd like to pull back, and we're going to assign that to our string make. At this point, we're going to build our authentication object. So we're going to create a new custom authentication token, and I'm just going to name this token. Then we're going to use the constructor, which will allow us to pass in the username, the password, and the make. So this is that first constructor we created over in the custom authentication token class. Next, we're going to use another method within the superclass, which is setDetails. This simply puts some information into our authentication object about the actual request itself. So I'm going to set the details, and we're going to pass in our token. And then at this point, we're going to get the authentication manager. Then we're going to invoke the authenticate method. So this is actually going to call the authentication provider that has been set up within our authentication manager. And we're going to pass in our token. Now we have configured a authentication filter, which can be registered within the filter proxy chain, and it's going to build that authentication object that we have just created. At this point, we have created our custom authentication object, and we've also created our filter that will be able to incorporate that object into the Spring security process. We'll pick up in our next lesson where we left off. In our last lesson, we built several objects that will allow us to integrate a custom authentication object into the Spring Security framework. In this lesson, we're going to continue that work by modifying our authentication provider and our SecurityContext.xml file. So if we look at our authentication filter, you'll notice that we invoke the authenticate method on the authentication manager. And this is going to wind up invoking the authenticate method on our authentication provider. But first, we need to make sure that our authentication provider supports our new custom authentication token. So we're going to change up the type from a username password authentication token to a custom authentication token so that our authentication provider supports it. Now that we know we will be receiving a custom authentication token as an argument to our authentication method, we can then switch up our casting. So I'm going to cast to a custom authentication token, and that's going to require me to switch this type. And then I can also return a new custom authentication token as our authentication object to verify that authentication was successful. We're going to use that second custom authentication token constructor that we created, and that constructor accepts the make as a parameter in the constructor. So we're going to use the accessor on the make field, and we're going to pass that into that second custom authentication token constructor. Now that we have switched over the types, we're going to incorporate the additional logic that will take into consideration that make parameter. We are going to throw an exception if our user is null. And then we're going to add an OR operator in there, and we're going to begin to build out our authentication logic. Our authentication logic is pretty simple. If the passwords do not match or the make of the user's car is not Subaru, we're not going to accept this user's authentication. We're only going to allow Subarus to be worked on within our auto service center. What I'll do is I will check the token and I will get the make, and then I'll just use equals ignore case, and I'm going to check for Subaru, and then I'm just going to negate that whole statement. So at this point, our authentication provider has been modified to support our custom authentication token. Now it's just a matter of configuring our custom authentication filter within our securitycontext.xml file. So now let's navigate to our securitycontext.xml file. The first thing that you'll notice within this file is that I have included some of the configuration for the authentication filter ahead of time. The configuration is quite large, and this is not something you would typically remember. Instead of typing this out, I'm just going to speak through the different pieces of configuring this filter. So you'll notice that we created a bean, and the bean points to our custom authentication filter type. Now remember, that type extends the username and password authentication filter, and in turn, that extends the abstract authentication processing filter, which is further up the type hierarchy. What we're setting actually is a lot of the properties on that abstract authentication processing filter. So it asks for a filter processes URL, and this is simply the URL that will handle the login post. So when we post our login form, it's where we're going to direct that request to. We've configured that within our form login up above. You'll see a lot of these being copied from the form login. They're very similar within our custom form login bean, and that's because the namespace is doing a lot of this translation for you. You'll also notice that we need to provide a reference to the Authentication Manager. So we're going to go ahead and give our Authentication Manager an alias of Authentication Manager. You'll also notice we specify the username parameter for our form, the password parameter for our form, as well as a success handler. And this success handler says where we should navigate after we have authenticated the user. And here we're just saying go to the root context. We also have an authentication failure handler, which is very similar, except it says where do we go when authentication fails. Now, one of the new items we've added here is a login URL authentication entry point. And you see this bean, we're providing a value of /login. This is simply a bean that says where do we go when we need to authenticate a user. So a user attempts to access a protected resource, we need to direct them to that authentication process, and we start by sending them to /login, which will show our login form. We actually need to register that bean within our HTTP tag. So I'm going to go ahead and copy the ID of that bean, and we'll navigate up to the HTTP tag, and there's an attribute on this tag, which is the entry point reference, and we're just going to point to that bean. Now, while we're here, we're also going to remove the auto-config attribute because we're no longer auto-configuring our authentication. Instead, we're going to be spelling it out within our filter. The final thing we'll need to do within our configuration is remove our form login tag because we are going to rely upon our new authentication filter to perform our login. We need to remove that tag, and then we're going to add a custom filter tag. And this custom filter tag needs to point to our new custom filter bean. So we're simply going to take the ID of that bean and place it in the ref attribute so that we point to this new custom filter and add it into our filter proxy chain. Now, when we specify a custom filter, we also need to provide a position for that filter. The position we're going to specify is the form_login filter, and this designates that we're going to be using this filter on form login. So at this point, we're going to restart our server, navigate to the browser. So let's first attempt to authenticate using our JRDO user, and I'll supply the password of password, and we're going to say that their automobile make is a Chevy. You'll notice that our custom authentication provider restricts the authentication for the user because of the make of the car they provided, which was contained on that custom authentication object. Now let's try the same credentials with a Subaru as the make. And there we see we can log into the application. So we were able to create a custom authentication object and register that object via a custom filter and some modifications to our authentication provider. This lesson should provide you with the groundwork if you need to modify the authentication processes of Spring Security. I can't predict every authentication need you will have, but you should be able to use this lesson as a template if those needs arise. In this chapter, we will focus on using JDBC Authentication within Spring Security. We know that we can store our users and their authorities within a database. The JDBC Authentication piece of Spring Security says that if we adhere to some opinionated views about how we should store those authorities and those users, we can then subscribe to a number of features provided by the Spring Security Framework that really improve how we manage users and their authorities via JDBC. So our first objective is to understand the out-of-the-box features that Spring Security is going to provide for us to manage our users and their authorities within a database using JDBC. So we're going to be looking at a JDBC user service, and that user service is going to be connecting to the tables within our database. And Spring Security is going to provide some default user schemas that we adhere to. And because we follow those default schemas that Spring Security provides for managing our users, our groups, and our authorities, we can then leverage these out-of-the-box features and very quickly set up some of the security features within Spring MVC. Another interesting item that we're going to look at is different forms of storing our users and their authorities. Right now, we've primarily been looking at users from the view that we have a user and then they have a list of authorities. Well, in group-based access control, we actually start out with a group and then we assign authorities to that group. Once that group has authorities, we then associate users with that group. Now, this provides us with a more flexible and robust way to manage our users and their permissions. Finally, in this chapter, we will learn to securely store passwords within our database. So one of the big problems out there is that some sites are storing user credentials in plain text. If they store credentials in plain text, an attacker can get those credentials and then try them against other sites and services that I may use. This has become increasingly common where we enter the scenario where we're providing one site for our credentials on another site. So maybe we want two sites to interact, and we provide site A with our credentials for site B so they can perform some sort of interaction on our behalf. Well, if site A is storing our credentials in plain text, that's an issue because they're making us vulnerable, compromising our online identity. So we're going to learn how to encode the passwords we store and take a look at an even more secure approach, encoding and salting the passwords we store for our users so that we can ensure that their credentials are safe within the sites we develop. When we build an application, we need to store information about our users and the roles that our users have or their authorities. Often a database is a great candidate to store this information because developers are so familiar with writing SQL and extracting information from a database. We have seen several examples throughout the course of how we can leverage Spring Security to query some custom user tables within our application. Now we're going to take a step back and look at how we can use a standardized schema that is provided by Spring Security. So if we adhere to a particular database structure to store our user and authority information, we can then leverage some of the out-of-the-box features of Spring Security that just really integrate very nicely with that table structure and make configuring our authentication very easy. The first thing we're going to do is we're going to turn to the Spring Security reference or the documentation. We're going to see there is a JDBC DAO impl, and this allows us to connect to a predefined schema within our database. Within this write-up in the documentation, you're going to see a link for the database schema appendix. And if you click on that link, it's going to take you to the recommended table structure that will allow you to integrate seamlessly with the Spring Security JDBC user service. We're going to copy this SQL snippet, and then we're going to navigate to our init.sql file. So this script gets executed every time we start our application. So we're going to add these tables into our SQL script so that they are built. So there we have the create users table and the create authorities table statements. And you can see they're adding an index as well as a constraint between these two tables. So it's pretty simple. 3 columns within the users table. One says, what's the username, what's the password, and then there's this enabled column, which is a Boolean. In the authorities table, we have a foreign key to the username in the user table. And then we have the authority column, which is going to store things like, role_admin, role_user. So we're specifying the particular authorities for a given user. I'm going to add a statement here to drop these tables once we run our script. That way we are sure that they get cleared out. So just drop table, then the table name, and then if exists. And I'm actually going to add these to the top of our configuration. And now what we're going to do is we're going to write insert statements in order to put some users into these tables when we start our application so that we can test with them. So insert into users, and then username, password, enabled, and then we're going to supply some values. So the username, we're just going to go with end user for new user, a password of password, and then for the enabled field, we're just going to supply a 1, which will equate to a true. Now we need to enter some authorities for this user. And in the authorities table, we have the username column and we have the authority column. We're going to provide some values there. The username will be end user. So we complete that foreign key relationship. And then we're going to specify that this is an admin user. And then we add our semicolon at the end. So here we have made changes to our database. Now, obviously, this is a temporary database that gets launched with the application every time and then clears out. But these insert statements will execute and load this data for when we start our application. And at this point, we will only have one user registered in that default schema we're going to use. Now that we have modified our SQL and our database to be able to store this information, now we need to navigate to our SecurityContextHolder file, and we're going to specify a different type of user service. So you can see that we reverted back to our in-memory user service. We're just going to remove that. We're going to leverage another tag within the security namespace, and that tag is the JDBC user service. And it asks us to specify a value for the data source ref attribute. You need to establish a data source bean within your application context.xml file. So here I'm using the JDBC namespace, and we are setting up a connection to our H2 database. And I gave that bean an ID of data source, and I'm just going to specify that bean reference within this configuration file. So at this point, that is everything. You can see if that database were in place and that structure were in place, it would be simply adding this one line and we would be ready to go. So let's restart our server and we'll just run through and try to log in with the end user just to test out our configuration. And at that point, we log into the application using Spring's standard schema for users and authorities. And we're going to see how we can expand upon this to increase the robustness of our authentication and access control within Spring Security. Out of the box, Spring Security provides us with a number of ways to manage our users and their authorities within a database. We have seen the JDBC UserService tag, which declares an authentication manager, and that authentication manager relies upon a standard schema that Spring is familiar with. In this lesson, we're going to take a look at another option that creates a more robust opportunity for managing our users and their authorities. And this approach is by using group-based access control. So instead of individually assigning each user an authority, such as we currently have set up, we're going to interject a group between the users and the authorities. So basically, we're going to create a group, assign authorities to the group, and then we're going to assign users to the group. If you have a large number of users within your application, you can easily grant permissions to a set of users based upon that group. So instead of going through and finding every user I want to give a particular authority, I would just grant that authority to the group, and then it is then realized by every user within that group. Just like our initial setup, we're going to consult the Spring Security documentation. You're going to see that there is this group authorities by username query attribute upon the JDBC UserService tag. We're going to apply the default query, so I'm just going to copy this query out. This is going to query against a standard schema that Spring Security will expect. Just by having this attribute defined within our configuration, it is going to signal to Spring Security that we are using group-based access control. So I'm just going to create a new line within the SecurityContext.xml file, and then I'm going to use the group authorities by username query, and then we're going to provide a value. We're just going to clean that up. And if you inspect this query, you will see that it is basically joining a groups table to a group members table and a group authorities table. Now, if you saw our init.sql file, you'll notice that we don't have these tables in place. So that's our next step. We go out and get the standard table definitions that Spring will provide via their documentation, and we're going to place them within our database. So in our case, that's in our init.sql file, which will initialize our H2 database. If we were to look for the JDBC DAO impl within the Spring Security documentation, you'll notice that you can navigate to the database schema appendix. And I already have that open here on this tab. And within this information, they will provide the schema for the group authorities tables. So here we see that we need to add these 3 tables to our init.sql file. And I'm going to add them under our authorities table, and actually below that index it's creating. And these also need cleanup. So we now have introduced 3 tables. The groups table, which will store all of our groups that we define. We also have a group authorities table, and this is going to assign the authorities to the group. And then a group members table, which will define which users are in the group. So now that we have these tables in place, we need to add some groups, we need to add some authorities to the groups, and we also need to add some group members. So we're going to write some insert statements that will establish those relationships. So the first thing I'm going to do is just delete our authorities insert statement. And now we'll start out writing our insert statements. So let's first create a group, and the groups table takes an ID. It also takes a group name. So we just provide some values here. So let's make a group the admins. And now we're going to grant some authorities to these admins. So we're going to insert into the group authorities table. And that table has a group ID column as well as an authority column. And then we need to provide some values here. So obviously our group ID is going to match our admin group. And then for now, we're just going to grant the user role to the admins. Next, we're going to add members to the group. And then we need to specify the columns in there, and that's the ID, the username, and the group ID. So the ID is just an arbitrary number. The username has to match one of our users, so let's go with end user. And then we need to specify the group ID that end user will be a part of. So there we've linked our end user to the group, and that group has authorities. So those permissions will then be granted to our end user. And what I'm going to do while we're here is I'm going to create another user. So we'll just call him a user for another user. And we're also going to put a user within the admins group. And now before we restart our server, let's actually change this ID to be unique so that the group members table has a unique ID key. So I'm going to change that to 2. And now we'll restart the server and we'll just log into the app here. And we're going to sign in using the A user we just created. Now, if we tried to access the schedule, we wouldn't have that permission. We should also notice the same thing if we try to log in with end user. So end user logs in, and then we try to hit the schedule, and we're not allowed. So here is the power of using group-based access control. I can come back now, and I can add another authority into the group authorities table for the admin group. And now if we restart our server, you'll notice that both a user and the end user can access the application and its admin features. And we only had to make that one change. So let's sign in as a user, and now we'll hit the schedule, and you'll see that we have been granted access. So had we had 1,000 users in that situation, all it would have taken is one simple change, whereas under the old form, we would have to change each individual user. So there's some real power in group-based access control if you have a large user base. If you have any background in cybersecurity, you know that we have been violating one of the most common principles, and that is we've been storing our users' credentials in plain text. When we insert a password into a database in plain text, it opens up a number of problems for our application. The biggest one is that if our application is compromised, most attackers will then take these credentials and bounce them against other sites. Most users reuse their usernames and passwords. So let's say our auto service application is hacked. A user accesses our database and they get the credentials of all of our users. So now they have their username and their password in plain text. Normally, the first thing they're going to do is take them then to Gmail or other online services that we use, maybe our banks, and they're going to try to log in with those credentials. And a lot of the time, they're going to be successful. So by storing our users' credentials within plain text in our database, we're really exposing a lot of security risk. And we're also opening ourselves up to insider threats because they could perform, that same process. Luckily for us, Spring Security provides an out-of-the-box mechanism that allows us to encode our passwords, and it allows us to compare encoded passwords. So to set up the comparison for encoded passwords, it's very simple. We just navigate to our SecurityContext.xml file, and within our authentication provider, we're just going to add a new tag within the security namespace, and this is the password encoder tag. And on the password encoder tag, there is a hash attribute. And you can see there are a number of values you can pick from, and these all represent different hashing algorithms that can be used. In our example, we're going to use SHA-256. So I'm going to pick the hash, and then I'm going to specify SHA-256. And at this point, when a user enters their credentials, their password is going to be encoded and compared against our value in the database. So let's see what happens when we run through this scenario. So I'll restart our server, I'll navigate to the application, Now we're going to attempt to log in with end user. Okay, it doesn't allow us to log in. Well, why is that? That's because Spring Security is taking our password and encoding it into SHA-256. And then when it compares to the value in the database, we have password, where Spring Security is storing some long alphanumeric value that makes really no sense to us. So what we need to do is we need to determine the value of our password when it is encoded. So I'm just going to make a quick class within our source test Java package, and I'm going to call this password encoder. And within this class, I'm going to add a main method. And we're going to take a look at some mechanisms that we can use to encode our passwords. So we can use a SHA password encoder, and we'll just call that encoder. And that has a constructor, which is a new SHA password encoder. And then we pass in 256 to that constructor to specify the type of SHA encoding we're using. And then we can get the encoded password by using the encoder to encode our password. And for right now, we're just going to put in our user's password and then specify a null value as the second argument, which would normally be our salt argument. And then we're simply going to print out the encoded password so that we can view it, so we can put it into our database. So I'm now just going to run this application as a regular Java app. So I can just go to run as, and then Java application. And if we look in our console, you'll see that it is going to spit out this long garbled string. And if we take that string and we put it in for our user's password, we will then be able to authenticate, because we now have the word password encoded with SHA-256. So let's save that. And now we're going to restart our application, navigate to the browser, and we're going to attempt to sign in again with our end user. And there you'll see that we are able to log into the application now that we have stored a encoded password. Within our applications, we need to remember when we create a new user that we use the encoding to encode the password, and that's what we use to store the password within the database instead of storing that plain text. Now, obviously, I have just used a simple class here to encode the password for this user. Ideally, this would be placed within a controller and used when we create a new user in the application. But given that we're using a static database with some already entered credentials, this was just a simple mechanism to encode our password and store it within the database using SHA-256 encoding. Encoding the user credentials that we store within our databases is definitely a best practice, but there are still some vulnerabilities that occur when we encode using something like a common hashing algorithm like SHA-256. For example, if we were to navigate to any website that allows us to hash out a particular string, we can just put in, let's say, password as the text, and it's going to return us the hash values of many one-way hashing algorithms. And there you see there is SHA-256. So if I were to take this value and we return to our application, and now we compare this to the hashed password within our database table, we get the same values in our database that we just received. What attackers normally do is they will build out basically dictionaries of common passwords, and then they can just run and check against any databases they have compromised that contain user passwords for these common hashes. So there we see it's an exact match. So it's not really going to stop an attacker just having our passwords encoded. This is where a technique known as salting comes into place. And the basics behind salting, you add some unique data to your hash. So maybe I'll add like an 8-character random number to the beginning of my password, and then I will hash that using SHA-256. And when we do the hashing, we make that 8-digit string unique for each individual user. This means if an attacker were to get all of our encoded passwords within the database, they would need to decode each individual value that has been salted, because it's not like the same salt has been used across every password. So in order to find the matches, they would need to treat each individual salted password as its own problem. And that's going to really expand the amount of time it takes them to basically find out what the clear text password is. So all we need to do is create a bean, and we're going to call this bean password encoder. And then for the type of this bean, we're going to use a standard password encoder. So I'll just declare that bean, and then I'm going to grab the ID of that bean, and we will change our password encoder tag to a reference to our password encoder bean. So at this point, Spring Security will be using a standard password encoder, which does salt the passwords that it is provided. And we can see that in action if we visit our password encoder class. And all we're simply going to do is change our SHA password encoder to a standard password encoder. So I'll just modify the constructor, and we don't need to provide any arguments to this constructor. And then instead of invoking the encode password method, we simply invoke the encode method, and that is going to salt and hash our password. And we also don't need to provide that second argument. Now, if we were to bring up our console and we ran our password encoder on our password, there you see we get a different hashed value, and that's because there was salt added to that value that we are encoding. And if we run it again, you'll notice we get a different encoded value, and once again we get a different hashed value. So all we need to do is take that value, copy it, and then we can head to our init.sql file, and we can replace that with our encoded password. At this point, we now have the salted, hashed password within our database. So we're going to restart our application, and we'll simply attempt to log in with our end user here that we have provided that password for. So now I'm just going to navigate to the application. I'm going to log out end user, and then we'll sign them back in. And there we see we were able to use a salted and hashed password with our standard password encoder in order to add some additional protection for our users' credentials that we are storing. So this is definitely a best practice, even more so than just hashing your password values. When we use those standard hashes, there are what's referred to as rainbow tables out there, and they're basically dictionary tables for these hashes that an attacker can just bounce a particular hash against until they wind up with your clear text password. That becomes much more difficult and much more time consuming when we use a salted hashed password. In this chapter, we're going to learn how to integrate Spring Security with an LDAP. LDAPs are great because they provide directories of the users, systems, and networks within a given organization. They serve as a central point of reference for a lot of information about the types of principals that will need to be authenticated within our applications. So instead of each application storing user information within their database, an LDAP can be established for an organization so that information can be shared and reused. So this makes it a great candidate for integration with our authentication processes and Spring Security. The first thing that we will do within this chapter is we will stand up an LDAP, and then we will integrate that LDAP with Spring Security using very little configuration. You're going to see a lot of support out of the box for LDAP authentication and authorization. Once we have established a connection to the LDAP we are going to stand up, we're going to see how we can then authenticate with our LDAP when a user provides their credentials. We can store the credentials within the LDAP, and we can use that information to make our authentication decisions. And we pretty much just use a few attributes within the LDAP to make that decision. But what we'll see is that an LDAP can store large amounts of data about our users, and we can actually integrate them into Spring Security using a UserDetailsContextMapper. With this mapper, we're able to pull in more information about our users from the LDAP and then weave them into Spring Security using the UserDetails interface as we have seen in the past. It really becomes seamless to connect your application-specific user classes with an LDAP. We'll also take a look at how we can fine-tune our LDAP configuration. Out of the box, if we set up certain structures within our LDAP, there is very little that needs to be done to work with Spring Security. But if our LDAP has a different structure, there are other attributes within the LDAP configuration in Spring Security that we must specify. So we'll talk a little bit about those attributes and how we can customize Spring Security to work with an LDAP that may follow a different structure. Before we dive into the lessons in this chapter, I just want to take a minute to remind everyone that they need to load the working files for each chapter. We're actually going to revert back to an early version of our application just to kind of unclutter some of the other technologies that we pulled in that really would not be useful when working with an LDAP configuration in Spring Security. So make sure you're loading up the working files for each lesson. In this lesson, we will install an LDAP server as well as an LDAP tool that will allow us to view the contents of our LDAP server. We're installing this software so that we can integrate with Spring Security's LDAP features. In order to get our LDAP, the first thing we'll do is we'll go to Google and we'll search for the Apache Directory project because we're going to be using an Apache LDAP server. So you'll see this first link says welcome to Apache Directory. Click on that link and now you'll see that you are navigated to the home page. From here, the first project that we're going to download is the Apache DS project. This is an LDAP server written in Java and it is LDAP v3 compatible. So it's also built by the folks at Apache, so that means all of the code is open source. So let's click on the Download Apache DS link, and it's going to bring us to this Downloads page where you can select your preferred installation. I normally go with the zip distribution. I click on Downloads for Archive, and then here is a link to download the zip distribution of Apache DS. Now, I'm not going to save this file because I have already placed it on my desktop, so you don't have to wait for me to download the file. Once you have downloaded Apache DS, I'd recommend putting it on your desktop. Then you can navigate back to the home page for the Apache Directory project. And you're going to notice that there is another project alongside Apache DS, and that's the Apache Directory Studio. This is to view the LDAP and allows us to see all the different nodes within the LDAP and see how it's organized, as well as it allows us to modify the LDAP. You can click on the Download Apache Directory Studio link, and here once again, you'll go to your operating system. If you would like, you can integrate it into Eclipse. You see that option's available there. I'm going to click on the Download for Windows option, and then I would use the Windows 64-bit installation. Once again, I'm not going to download this file because I already have it. With the Apache Directory Studio installation downloaded, you can then return to your desktop, and from here, you'll see the two distributions loaded, and then just use your favorite zip tool to extract them into their own directories. We want to go to the directory where our LDAP server was installed. If we see the Apache ds-2.0.0 directory, we double click there, and now we go into the bin directory. you're going to see a batch file. So just double click on that batch file, and that's actually going to start your Apache DS server. We can see that the server has started. So now we're going to navigate back to our desktop, and at this point we're going to launch our Apache Directory Studio. Close the welcome screen. The first thing you'll want to do is go down to the LDAP servers. Just click on the new server icon here, and then click Apache DS 2.0. Now with that clicked, navigate to your console and close the cmd.exe window. Now right-click on the server and hit Run, and this will attempt to start your new server. Okay, there we see that our server has been started, and now we can make a connection to that server. So right-click on the server name and then hit Create a Connection, and it will inform you that you have created a connection to the server. And then if you click on the Connections tab, you'll notice the Apache DS 2.0.0 connection. And in that connection, you're going to see the contents, so all the nodes that are out on that LDAP server. And within here, we'll be able to configure the server to add new users, to add new organizational units, and to inspect the contents of what's on the LDAP server. So this completes our installation of Apache Directory Studio and Apache DS, which are two tools that we'll be using to work with Spring Security and an LDAP. In this lesson, we will configure our LDAP for use with the Spring Security Framework. After we configure the LDAP, we will take a look at the structure of the LDAP and see how it stores the information regarding our users in our system. So click on the LDAP Servers tab, and then just right-click on the LDAP server and hit Run. Once the LDAP server has started, I'm now going to click on the Connections tab, and if I just double-click on that connection, we'll see it open, and we can now see the structure of our LDAP within the LDAP browser. We need to create another domain controller, and we have to create that within a partition. So we're going to add a partition to our LDAP server. So just double click on the server, and then you'll see this partition tab within the editor. Click on that partition tab and hit Add. And we're going to ID our partition as O'Reilly. And for the suffix for the partition, we're going to change it to O'Reilly. And then we will leave the comma DC equals com in place. So go ahead and save the changes to our config.ldif file. Now go ahead and stop and then restart your LDAP server. Once the server has started, navigate back to the Connections tab, and then just double-click your connection to refresh. At this point, you'll see that we get a new partition and a new domain controller within our LDAP structure. So a domain controller is used to group a collection of machines or user accounts that we want to group together. Once we have included our domain controller, let's import our LDIF file, which is going to contain the information about our users, their authorities, and the groups within our permissions model. So simply right-click on root DSE and then go to Import and click LDIF Import. This will open up the LDIF Import dialog. And let's talk a little bit about LDIF. LDIF is the LDAP Data Interchange Format. Basically, it allows us to specify the structure of our LDAP in a plain text file. So there's going to be a number of entries within this file, and each entry is going to have different attributes. And attributes are basically name-value pairs that have a type. So you can almost think of them as a database column and think of our entries almost as a table. Now, each entry is also going to have an object class. LDAPs are very much object-driven, so you'll have an entry that's an object class, and then that object class will have a bunch of attributes. You can almost think of this like a class in Java having many fields which have their own type, and those fields can then have a value. So let's import our LDIF file. You'll want to click on the Browse button within the dialog, and then navigate to the spring-security.ldif file, you will find this file within your working files for this lesson. So simply click on the file and then click on Open. You may have to overwrite a log file if you have already imported this file before. The Apache Directory Studio is going to write out this log, and I'm just going to mark that I want to overwrite it if it exists. Once you have completed this step, you can click on Finish. If you inspect your LDAP browser, you'll notice that we now have an organizational unit named Groups and an organizational unit named People. So these are entries within the LDAP. If we click on our groups, here we see the object class as an organizational unit, and then here we see an attribute OU, and that attribute is set to groups, and that's the name of this organizational unit. Now, within our groups, we have two groups listed. These are also entries, and you see they're of object class group of unique names. And here we have the CN attribute, which is the common name attribute. This is basically the name of the entity or the entry that we're storing. We're storing the name of basically our authorities here. So if we were to prefix this CN with role underscore, we'd have role underscore admin, which corresponds to one of our authorities within the application's configuration for Spring Security. You'll notice that for each group, we specify some unique members, and these are basically the members of the group. And here you'll see this string that basically navigates down through our LDAP. So here it's DC equals com, DC equals O'Reilly, OU equals people, and then UID equals K Bowersox. So if you just follow that down through the LDAP structure, so DC equals O'Reilly, DC equals com, then we go to OU equals people, and then UID equals to Kevin Bowersox, we're going to point to another entry, and this entry is of type inet org person, and there are a number of attributes that are specified on this entry. The first is a CN, so that's the common name. SN is a surname, so a last name. And then there's this UID attribute, and that's actually the username for this individual. And then we have a user password attribute, and that contains the password. So here we are establishing the users within our system as well as their credentials. And then we map them to these different groups. So here we see when we look at the user group, there are actually a number of unique members here, and that corresponds with all of our users. But when we look at the admin group, we only have one user in that group. As we work through our Spring Security configuration, we're going to be using this structure within our LDAP and using snippets of it to specify within our configuration. In this lesson, we will configure Spring Security to use our LDAP server for authentication and authorization. To begin, we need to add a new dependency to our pom.xml file. And this dependency is going to contain all of our classes pertaining to setting up an LDAP server. So if you navigate to the pom.xml file and click on the Dependencies tab at the bottom of the editor window, you can then navigate to Add, and we're going to add the Spring Security LDAP artifact, and we'll select the artifact with the org.springframework.security group. So just click on OK, and that will add that dependency to our POM file, and then save our POM. At this point, you can close the POM file because we will no longer be needing it. And configuring the LDAP server is actually made quite simple by Spring Security. This is really the beauty of using the Spring framework within our applications, because there's just a lot of plug and play with our configuration that allows us to easily perform a large amount of work to our application. At the moment, you'll notice that our authentication provider is set up to use a JDBC user service. We are going to swap out that authentication provider, which is actually an instance of a DAO authentication provider, and we're going to use an LDAP authentication provider. So simply remove the authentication provider from the Authentication Manager, and then within the body of that Authentication Manager tag, you can select a LDAP Authentication Provider tag, and that's provided by our security namespace. Now we're going to configure our authentication provider. And the first attribute that you will notice within the authentication provider tag is a server ref. This is a reference to a bean that represents our LDAP server. So I'm just going to name this reference LDAP server, and that means that we need to configure a bean with the ID of LDAP server. Once again, to the rescue, here comes the security namespace. You'll notice the LDAP server tag. We'll go ahead and set up this bean to have an ID of LDAP server. Within this LDAP server tag, probably the most important attribute is the URL attribute, the URL of our LDAP server. It's very similar to a web address. So the first thing we provide is the protocol, and in this case it's LDAP, and then we use a colon, 2 forward slashes, and now we're going to specify basically the domain of this LDAP server, and in our case it's sitting on the local host, so we're just going to use the server name and then a port. After the server name and the port, we specify the domain controller. And that's actually going to be the DN of our domain controller. So let's navigate over to Apache Directory Studio and take a look at our server so that we can find this information. First, just make sure that your server is started. And then if you double click on your server, you'll get this configuration dialog. And here you'll see that our port is port 10,389. So just copy that over to your config and put the port in, and then navigate to our domain controller. And from here, you can copy the DN. And if we copy and paste all of this, it makes it pretty simple so that we don't have any errors because, we mistype something. Another thing you can do with this LDAP server attribute is you can specify a manager DN as well as a manager password. This is not required, but it allows you to provide credentials that will be used to bind to the LDAP server when we perform our searches. And what we'd like to do is we'd like to set this to the DN of the admin user for the LDAP and the password. Now I'm going to go ahead and tell you that the LDAP admin password is by default secret. So go ahead and type secret in for the manager password. And now we're going to navigate over to the LDAP, and we will find the admin located within the organizational unit system and then the UID admin. So let's go ahead and copy that DN, and we'll take that over to our configuration files. Okay, so at this point, we have our LDAP server configured, and it is specified as a reference on our authentication provider. Now, there's one more thing that we need to specify, and that is an attribute on the authentication provider itself, and the attribute is the user DN pattern. So this is a pattern that will be searched throughout our LDAP to find the user who is attempting to log in. When the credentials are supplied to the LDAP authentication provider, it is going to take the username and pass it into a placeholder we're going to put in the value for this pattern. That placeholder is going to be a curly brace, 0, curly brace. So if we were just to leave it like this, that would just provide the username of a user, and it would go search the LDAP for just that username against the DNs for every entry in the LDAP. It would not find anything. But since we have all of our users within this people organization unit, we can grab the UID of organizational unit people. Now, we don't need to add the domain controller because that will be appended by default, but we can take that, remove the domain controller, and then specify the UID is equal to our placeholder. What we're saying there is we're going to insert whatever username is supplied as the UID, and then we're going to look for comma OU people. You can also just infer that the domain controller is going to be prefixed on to this DN. Let's say we put in our kBowerSox user, it would look like UID is equal to kBowerSox, comma OU is equal to people. And what would happen is Spring Security is going to connect to our LDAP using the administrative credentials, and then it's going to begin to look at each DN. So here we see like our DN is performing a query. And then here it's finally going to get to a DN that matches because we see UID is equal to kBowerSox, comma OU equal to people. And it's going to return that user, and that user's credentials are going to be used for authentication. And then if we authenticate, we will consider their authorities for authorization. So we have our configuration in place. Let's go ahead and save our SecurityContext.xml file. Now we'll run through an example and log in using our LDAP server. So all of our authentication will be provided by our LDAP. So I'm just going to restart our server, and I'm going to attempt to sign in. We'll provide the credentials for the kBowerSox user, and the password is password. There we see we're able to log in to the application, and that authentication was performed using our LDAP authentication provider. So this is the basic setup of using an LDAP with Spring Security. In this lesson, we will learn to use Spring Security's UserDetailsContextMapper. This object is used to map data from our LDAP to and from our user objects within our applications. Currently, when we use LDAP authentication, the only thing that gets stored within our security context is our UserDetails object, where we can only access the username, which would map to the UID, and the password, as well as the granted authorities. We're going to map our LDAP data to a custom user class like our auto user class within our application. We're going to navigate to our Apache Directory Studio, and we're going to make some changes to our LDAP. So if you start your server and then navigate to the OU people entry, go to our first user, which is Jane Doe. We're going to add a few attributes here. Just right click on one of these blank lines and hit new attribute. Then we just type out the name of the attribute. And the first one we want is the given name. That is very similar to the first name. So we're just going to put in Jane, and then we're going to add another attribute, which is going to be the mail, and that's where we will store email. So once we've selected mail, just hit finish, and then we'll make up an email for Jane Doe. Once you have entered these two attributes, just select them and then hit copy values. And then you can navigate down to Joe Doe, and you can then paste these values in, and we'll just switch them up for Joe and add this extra data into our LDAP. We'll do the same for Junior. So we'll just switch the email, and we'll switch that first name to Junior. And then we'll navigate down to the kBowerSox user, and we'll paste these values in. We'll switch up the first name to Kevin, and then we'll put in an email address for this user. So at this point, we've added these two additional attributes to each one of our entries that correspond with an inet org person user within our LDAP. So we just have some more additional information about the folks in our LDAP. We need to navigate to our auto user class, and now we need to implement Spring Security's UserDetails interface. And we'll import it, and then Spring Security is going to give us a warning that we haven't implemented every method. So we'll add all the unimplemented methods. And then the first thing we're going to do is we're going to add a new field, and it's going to be a private field of type collection. We are going to use a wildcard here for our generic type that extends granted authority. And we're just going to call this collection authorities. So we'll put that in place, and that's going to store all of the user's granted authorities that will be returned by the LDAP. Now, we're not going to store this anywhere in our database, so we're just going to mark this as transient with our JPA annotations. So we'll save that. And now we're going to navigate down to some of these methods that were added for our UserDetails interface that we must implement. And you remember the majority of these. What we're going to do this time is we're going to add a setter method for the authorities. So you can just hit Shift-Alt-S and then R, and that will pull up the Generate Getters and Setters dialog, and just click on Authorities and make sure the Set method is checked. Hit OK, and now we have our Set Authorities method. If you're familiar with using Eclipse, you've used these shortcuts a million times. Now we're going to return our authorities collection from our getAuthorities method. And then for all of these methods that return a Boolean, we're just going to make them return true. That way we don't have any problems accessing our user. If you don't have these in your data source for your users, it is quite all right just to set them to true. So at this point, we have completed the configuration of our auto user class, and we have added those additional attributes into our LDAP. Now we need to put the objects in place that are going to map that data to our auto user object. So let's go ahead and add a new class, which we will use as our UserDetailsContextMapper. So I'm just going to go within the source main Java source folder, and right under com.o'reilly.security, I'm just going to create a new class using the new dialog. So Control N, and then type class. Now we're going to create a class named Custom UserDetailsContextMapper. And this class is going to implement the UserDetailsContextMapper interface. So just hit finish once you have selected that interface. And here we see our class, and this is what we're going to work on to provide the implementation of these two particular methods. The first method maps the data from the LDAP to our UserDetails object, and that is the MapUserFromContext method. And then the second method maps our user data to the LDAP. We're going to look to implement these two methods, and they're going to allow us to convert LDAP data to and from our auto user object. In this video, we will pick up where we left off in our last lesson. We were creating a UserDetailsContextMapper that would map the information in our LDAP to a auto user object. We have these two methods that we must implement from that interface. The first is the MapUserFromContext method. It has 3 arguments. The first is the dir context operations argument, and that is basically how we're going to interact with our LDAP. Then we get the username as well as the authorities of the user. We're going to construct an auto user object, and then we're going to set the fields on this new auto user by pulling information from the LDAP. So here we're going to invoke the setFirstName method, and then we're going to reach into the LDAP using the getString attribute. And all we got to do is provide the name of the attribute on the LDAP. So for the first name, it was the given name attribute in the LDAP that mapped to our user's first name. So we're going to do this for each of our fields. So we'll do it for the last name. That was the surname attribute within the LDAP. We also had the email field, which is mapped to the mail field in the LDAP. And then we have the username on our auto user object. And we don't need to reach into the LDAP for this one. We can just use the username that is passed into this method as an argument. Finally, we're going to set the authorities on our user. And we need to just pass in the authorities that were provided to this method as an argument to our setAuthorities method. And there we have constructed our auto user. We have provided information to Spring Security for how to take an LDAP entry for one of our users and map it to an auto user class, and that auto user is going to be placed within the security context holder on the authentication object's principal. Now we need to provide an implementation for our second method, which is map user to context. So now we're doing the reverse. We're going from an auto user object. So let's declare an auto user. We're going to cast our user object that is passed as an argument to this method to an auto user. And we can do that because we know that the object stored in the principal on the authentication object is of type auto user. And now that we have the auto user object, we're going to use our dir context adapter to set the attributes on the LDAP entry, ctx.setAttributeValue. We provide the name of the attribute as the first argument. So for the first name, we'll use given name once again. So we're going to call the getFirstName method on the auto user object. So we're going to do this for all of the fields on our auto user class. So there we just pulled in the last name. Now let's get the email. Now we're going to set the password. And then finally, we want to map the username to the UID. So there we've provided our implementation of the map user to context method. And at this point, we have almost established our custom UserDetailsContextMapper. We do want to make sure that this class is declared as a bean, and we're going to give that bean a name of ContextMapper. Copy that onto your clipboard because we're going to use that in our later configuration. Now that we've set up our UserDetailsContextMapper, we're going to navigate to our SecurityContext.xml file. And the first thing we're going to do here is we're going to add the context namespace. That way we can perform some component scanning. So go to the namespaces tab and then make sure that your context namespace is checked for this configuration file. And then head back to your source. And now we can use the context namespace to component scan. That way we can pick up our new UserDetailsContextMapper, and we're going to component scan the com.o'reilly.security package to pick up that bean. With that bean in our IOC container, we can then associate that with our LDAP authentication provider. And the way we do that is by specifying the user context mapper reference, and then we just provide the name of our bean. So I'm going to go ahead and save our SecurityContext.xml file. And at this point, that's all of the configuration changes we need to make to that file. Now we're going to navigate to our appointment controller class, and we're going to head to the save appointment method. So here's where we're creating a new appointment for a user. And as we saw before, we're basically hard coding in this user, but we're going to change it now to pull our auto user from the security context. So we're going to use the security context holder, and then we're going to get the context, then get the authentication object, then get the principal. And that's going to pull that auto user out of the security context holder that was able to be placed there because we defined the mapping within the UserDetailsContextMapper. We're going to go ahead and save this controller class. Now we're going to navigate to our browser after we restart our server. And here at the browser, we're just going to attempt to sign in. And we're just going to use the kbowersox user. And the password is password. So there we've logged in. And now we're going to create a new appointment. So we'll just pick any old date. Once again, go with a Subaru. We'll say it's an Impreza. It's a 2014. We will get the oil changed. So now we'll save our changes. And there we see that we were able to use the information from our UserDetails object within the controller, and we pulled that object from the security context holder, and it's actually a custom implementation of the UserDetails interface, this auto user class, which is specific to our domain for the application. And that's all made available by a UserDetailsContextMapper. In this lesson, we're going to learn to fine-tune our Spring Security LDAP configuration so that it may handle any situation an LDAP throws at us. Currently within our SecurityContext.xml file, we are not providing much configuration of our LDAP authentication provider, and that's because our LDAP really conforms to some of the defaults that Spring Security expects. Unfortunately, if our LDAP does not conform to Spring Security defaults, we need to provide some additional configuration. You'll notice that we're using the UserDN pattern attribute. This is a great way to bind to the LDAP if you store all of your users within a fixed location. So we know that all of our users are within the people organization unit. And the UserDN pattern attribute just plops the username into this parameter, matches it with the UID, and then goes to this organizational unit. But what if not all of our users were stored in that organizational unit? For example, if we navigate to our LDAP and we expand the O'Reilly domain controller, and we create a new entry, and just hit next, and we're going to make an organizational unit. We're going to set the DN for this organizational unit to be others. And we're just going to hit finish there. And now we're going to place a user within that organizational unit. So I'm just going to copy one of our existing users, and I'm going to paste them into our new organizational unit. I can go in and let's just change this up a little bit. We'll make this other doe. And we'll change the given name to other. And we'll change the email to just odo. And we'll set the username to odo. We need to remove that UID it put there. So we just have odo as the username, and then password will be the password. This user is within a different organizational unit. So how do we account for that within our Spring Security configuration? So the first thing, before we head back and do that, I'm just going to bounce our LDAP server, so that config takes. And now we'll head back and discuss this within our SecurityContext.xml file. We can no longer use the UserDN pattern attribute. It's only for fixed locations within the LDAP. What we can use is the user search filter. This allows us to basically enter almost like a where clause or a predicate that's going to be used to identify a matching record within the LDAP for our user. So we put within parentheses our criteria. And we're just going to use UID is equal to the first parameter passed in, and that is going to be the username. What this will do is it will navigate through the entire LDAP and try to match any entry that has a UID equal to the username. So we're no longer restricted to a certain organizational unit. Now, while we're doing this, let's take a look at another attribute that we can provide when configuring Spring Security. We can specify a group search base, and this is where the Spring Security framework is going to look for the authorities for this user. Currently, it is set to search the entire LDAP. Now, if you wanted to limit this down for performance reasons, you can then specify an organizational unit where we start our current search for the authorities that a user may have. And let's navigate back to the LDAP to make sure we get this right. We're looking at our OU groups attribute. So you can simply grab the organizational unit equal to groups and place that within our Spring Security configuration. So now once we authenticate the user, Spring Security goes back and says, I need to find what authorities this user has. And because we have specified that attribute to OU groups, Spring Security will look within this organizational unit to find which groups the user is bound to, and it's going to do a search for the unique member attribute equal to the DN of the entry that is authenticating. In order for our ODO user to log in, we'll need to make sure they have a unique member attribute underneath one of our groups. So let's go grab their DN, and we'll just copy that from the record. And then we're going to add them to our user group. So I'm just going to add an attribute, unique member, and we'll hit finish. And then we will paste their DN into our LDAP. Once again, I'm going to bounce our LDAP just to make sure this took effect. And then we'll navigate back to STS, and we're going to restart our server. And now we'll attempt to authenticate with the ODO user. So for the sign-in name, we're going to use ODO. For the password, we'll use password. And there you see we can now log in with the ODO user that is in a different organizational unit. You'll notice that we have specified the group search base. Well, there's also the group search filter. By default, this is set to the unique member. We've already seen this. The unique member is equal to the DN of the authenticated user. This first parameter that gets provided to the group search filter is the DN, and that's going to match up with the unique member. It's going to go back to our LDAP and find where the unique member is equal to the DN for ODO, and that's how it gets assigned that user role. Now you might be saying, where does the role prefix come into place? Because when we specify our access, we're mentioning, role underscore user, role underscore admin. Well, that is contained using the role prefix attribute. So if you just set that to role underscore, it's going to take the name of the group and prefix it to role underscore, and that's going to match our configuration. Once the group search filter matches the DN to a particular group, we also need to select an attribute from that entry to use as our group name. So basically we're saying what gets prefixed with role underscore user. That is defined within the group role attribute. If we look at the group role attribute, and then we navigate to our LDAP, you'll see that really the group role attribute should be our CN, and that's what's used by default, the common name, because that contains really the name of the group. So we're just going to set that to the CN attribute. We pretty much just specified the defaults here for ourselves to look at. So let's take that comma out of our config, and now we will restart our server and then navigate to our browser. We're able to log in with the ODO user, and we had a lot of custom configuration of our LDAP provider within our Spring Security config. This chapter is all about authorization. And if you'll remember, authorization is how we determine if a principal has access to a resource. Up until this point, we've been focusing primarily on authentication. So with authentication, we validate the user's identity, and then we can retrieve some information about the user's authorities or their accesses within our system. And using that information, we bounce it against authorization roles or access roles, and then we can determine the resources a particular principal has access to. So in this lesson, we're going to learn how to make those choices about whether or not to grant a user access to a resource. So let's take a look at some of our chapter objectives. Throughout our work, we have seen how we can restrict some access to resources, and we've really been at that page level. Well, that's not always appropriate for an application, and we need to push our authorization decisions down into actually components on the page at that level and at the method invocation level. So that's what we're going to look at within this chapter, is how we make more granular decisions about access to a resource. To do that, we're going to leverage the Spring Expression Language, or SPEL. While SPEL is not itself a mechanism for making authorization decisions, it is used by the other mechanisms such as annotations that we're going to see within this chapter. So it's important we have a good understanding of this expression language. The primary thing to know about the expression language is that it has access to some of the objects within our security context holder. So we can access the principal, we can access the authentication object within the expressions that we create to make authorization decisions. Throughout the chapter, we will run through some demonstrations that show how we can use the Authorize tag within the Spring Security JSP tag library in order to conditionally render sections of a page. The neat thing about the Authorize tag is there are several methods of making that authorization decision, and we'll go through each of those methods so we have that familiarity and we know when to use which approach. One of my most favorite parts of Spring Security is the ability to apply authorization to method invocations. This is very powerful. We're able to look at information about our user and then decide whether or not they can invoke a method. So this applies to all of our Spring beans, and it's a very powerful feature because it grants us very fine-grained control about what a user can and cannot do. So we're going to be exposed to 3 annotations that will allow us to make those types of decisions. That's the pre-authorize annotation, the post-authorize annotation, and then the standards compliant RolesAllowed annotation, which functions very similarly to the pre-authorize annotation. Another neat feature that we'll take a look at is the ability to filter a collection using annotations. So we're able to use the PreFilter and PostFilter annotations to filter collections that are accepted as arguments to our methods or that are returned as objects from our methods. And this allows us to fine-tune a collection to the logged in or authenticated user. And this can be used primarily as a check to ensure that a user is not getting access beyond what they should have the appropriate permissions for. So this is a very important chapter because we're learning how to take the authenticated user and begin to make security decisions about what they can and cannot do within our application. I look forward to working through some of the examples because I feel this chapter really ties everything together. So let's get started. If you're familiar with Spring, you've most likely used the Spring Expression Language, also known as SPEL. SPEL is an expression language that was built to be used across all Spring products. It allows us to provide some flexible configuration options to different areas of Spring, such as our XML and annotations. In this lesson, we're going to take a look at how SPEL is used within the Spring Security Framework. So to begin, we're just going to make some modifications to our SecurityContext.xml file. When we look at our config file, we see some pretty basic setup here. We see the intercept URL tag being used to secure some different URLs or resources within our application. Now, when we look at the access attribute on the intercept URL, you'll notice that it's using static values. We're going to replace those static values such as role_user and role_admin with some expressions that are built into Spring Security that use the Spring expression language. In order to get started using expressions, we need to modify our configuration to allow expressions. So simply change the use expressions attribute's value to true. With that in place, we can now insert our first expression. And our first expression is going to be the has role expression. And we simply provide a string that is a role within our application. And within these expressions, we can use logical operators. So here we're just going to add an OR logical operator. And then we're going to specify our second role of admin. So this would equate to that constant that we had in place. Now, obviously, there is a little bit more verbiage to this, but we get a little bit more flexibility. We could add some ands in there, some nots. There's all sorts of different operators that can be used within spell. So we get some flexibility in our configuration. Now, we have seen the has role built-in expression. One that is very identical to has role is has authority. In Spring Security, when we talk about roles and authorities, they're pretty synonymous. When we are invoking the has authority method within our expression language, we are pretty much calling has role. And if we would look into the source code for Spring Security, you will see that has authority actually delegates to has role. So now let's look at another situation. At the bottom of our screen here, we're allowing anonymous access and the user role to access every other pattern within our application. Well, we can provide a very simple expression that will accomplish the same task, and that's the has any role. And basically, this is a short way not to specify all the ors between our has role statements. So here I'm just going to add role underscore anonymous, and then I'm going to add the next role, which was role underscore user, and we'll also throw the admin role in there. So for has any role, we just provide a comma-separated list of our roles and authorities to Spring Security Framework. With our expressions in place, let's go ahead and run through our first demonstration. So I'm simply going to restart our server, and we're going to navigate to our browser, and then we're just going to attempt to sign in. So I'll sign in as our admin user, and that's kbowersocks with a password. And once our login form shows up, so kbowersocks and password. And there we see we're able to log in now. We're using those expressions that are specified within our access attribute. So let's take a look at a few more of these. So I don't advocate for this next approach, but just to demonstrate some of the capabilities, we're going to take a look at how Spring can access different objects. So we can look at the principal object that is stored within our SecurityContextHolder, and I can reach in on that object and access the username, and now we'll just do a hard-coded check that the username is kbowersocks. I'll make sure I add that trailing single quote on there. And now if we run our application, we can test out that configuration. So I'm just going to log out. And once we get our sign-in page back, we can sign in. And now when we attempt to access the schedule, we are allowed because Spring Security evaluated this expression, saw that our logged in principal had a username of kbowersocks, and that allowed us access to that resource. Now let's look at one final expression. You'll notice here we're basically allowing anyone into this URL. What we can do is we can use a simple permit all, and this would be preferable because now if we come up with another user role, it's included within this expression. So it's pretty obvious permit all is going to allow everyone access. So let's restart. Once the application starts up, we can navigate to a different role. We just got to log out first once our server restarts. Okay, so now we're logged out. We're going to hit a resource that is not protected, and you see we don't have any problems, and that's because of the permit all expression. Now, I have not covered the entirety of all the expressions that are out there and built into Spring Security. But if you go to the expression-based access control of the Spring Security documentation, they're going to have a list of all of the different built-in expressions. So there we see has role, has any role, has authority. You can pretty much surmise what has any authority is going to do. You provide a comma-separated list of roles or authorities which are synonymous, and it's going to authenticate it. There you see the principal object. You can also use the authentication object. We saw permit all in action, deny all. Pretty easy to infer what that's going to do. Is anonymous. is similar to our role_anonymous we saw when we were just providing static configuration. Is remember me refers to a specific type of authentication. Is authenticated will allow any authenticated user. Is fully authenticated will not allow users that have been authenticated with remember me authentication. And then we get into these has permission built-in expressions, and they are specifically targeting when we have an ACL, so an access control list, and that's a little bit more in depth, and we'll see that later in the course. But for now, we got our first glance at the expression language that can be used to configure Spring Security, and we're going to be using this throughout the rest of our course. The Spring Security JSP tag library provides us with the Authorize tag, which is one of the most simple forms of access control we can use in the Spring Security framework. The Authorize tag is used to conditionally display a section of the user interface, or our JSP. In this lesson, we're going to learn about the different configurations of the Authorize tag and their advantages and disadvantages. So within this lesson, we are going to work within the appointment.jsp page to require authorization in order to view certain buttons within the appointments page. In order to get started, the first thing we'll need to do is add a page directive, which will include the Spring Security JSP tag library. So to do that, we just add a tag lib declaration at the top of the page, and then we specify a URI. So once you have the double quotes, just hit Control Space, and then autocomplete is going to kick in, and we can simply select the springframework.org/security/tags URI, and that will include the Spring Security JSP tag library. And we just need to specify a prefix for the tag library, which we will use as SEC, so security. Now, with that tag library in place, we can now use the Authorize tag to control access to different components within the page. So I'm just going to modify our buttons here so we can see what's going on. We have 4 buttons at the bottom of the page. One is a back button that everyone will have access to. There's also a cancel button, which a user can use to cancel their appointment. So in order to view this button, we are going to authorize that the user has the role_user authority. And then we have the confirm and the mark complete buttons. So the confirm is used by an admin to say, yes, we accept this user's appointment. And mark complete is used by an admin to say that we have completed this work. So we're going to protect those and require authorization based upon the role_admin authority there. To do this, we can use the Authorize tag within our tag library. So we're going to start out by protecting the mark complete button, and we're going to use the Authorize tag. And the Authorize tag is almost like a sophisticated CIF tag if you're familiar with JSTL. It's basically going to conditionally display the body of the tag depending upon some attribute values that we specify. The first one that we're going to look at is the URL attribute. So what the URL attribute does, it allows us to specify a URL, and if a user has access to that URL, then the body of the tag will display. So we're actually going to copy some configuration from our SecurityContextHolder file. Here we see that we are restricting anything requiring the schedule to the kBowersox user, and we're just going to specify that URL here. So now when Spring Security is determining whether or not to display this button, it's going to check whether or not our user has access to /schedule/*, so any URL that contains that. And it's going to basically refer to our configuration in the securitycontext.xml file, find this access attribute, and then execute or compare this expression language that we've provided to see if we return true or false, and that will determine how we conditionally render this button. It's a little bit odd. We normally wouldn't protect this with /schedule/*, It would probably be something closer to /appointments/complete, but we get the point across with that URL. Another way that we can use the Authorize tag is by specifying an access attribute. And this is very similar to what we see in the configuration file. It allows us to specify an expression, and that will determine whether or not the content is displayed. So we can use has role, and then here we're actually surrounding the back button. So let's surround our cancel button, and we're going to require the user role in order to display the cancel button. And we can use all sorts of the built-in expressions within that access attribute. So there we used has role, we can use has authority, basically anything that we can use in an expression, we can use within this access attribute on the Authorize tag. So there we see I'm using has authority. And now we're going to require that in order to display the confirm button, the user is actually an admin. So there we see all of our configurations in place. And now we'll just run through them in a demonstration. So I'm going to restart our server and then navigate to the browser, and we're going to log in with an administrative user to check that the authorized tag is appropriately rendering the buttons. So I'll log in with KBauerSox, who is an admin, and then I'll navigate to the appointments page, and there we see the confirm and the mark complete buttons displayed as we expected. We do not see the cancel button displayed, so we know that's functioning properly. Now let's talk a little bit about the URL attribute and the access attribute. When we are using the access attribute for the cancel and confirm buttons, we are using the expression language. Now, a problem with this is that if we repeat the same expression multiple times throughout the application, if we modify the expression, we need to modify it in multiple places, which exposes us to some errors. This limitation is overcome by the URL attribute, but you'll find that it's not applicable in every situation. So we're going to look at a new approach using controllers that will allow us to provide some more reusability. Within a controller, we are going to add the model attribute annotation, and we're going to create a model attribute named isUser. And then we're going to declare a public Boolean method named isUser, and we're going to pass in an authentication object to that method via dependency injection in Spring. Now, within the body of the method, we're going to perform some logic to make sure that the user has the role_user authority. And if they do, we're going to return true, and that's going to be passed into our model. So I'm just going to, on the authentication object, grab the authorities, and then check that it contains our role_user authority. And since that's going to create a list, I'll just get the first item in the list to pass into the contains method. So there we have performed our logic to determine if the user is authorized to access that resource. And now we just need to adjust our access attribute within our JSP file. So we'll go to the cancel button, and we're going to change the access attribute to use JSPEL and pull that Boolean isUser out of our model. Now we're going to restart our server and navigate back to the application, and we're going to test this out. So we need to log in with a user that does not have administrative privileges, so JADO password. Once the application restarts, it lets us in. We navigate to the appointments page, and there we see that the cancel button is displayed. And that's thanks to the controller logic we provided and the model attribute annotation. And this is a much more reusable approach than the other two methods that we looked at. So in this lesson, we learned to use the authorize attribute via a number of approaches, with the preferable one being configuring it within the appointment controller and passing a model attribute to our view. In this lesson, we're going to secure our service layer by requiring authorization in order to invoke different methods on our controllers. Using Spring Security, we can put authorization roles in place on any bean within our application context. So we know that controllers are a bean, and what we're going to do in this lesson is we're going to protect three methods on the appointment controller. So we see the confirm method, the cancel method, and the complete method. These methods are all pretty much just stubs, but we're going to protect these stubs so that we can prevent a particular type of user from invoking them. Now you may be asking yourself, why is this necessary? We have different authorization requirements in place at our page level. So for example, if we sign into the application and we use a normal user, so I'm going to log in as Jane Doe, password of password, and she's going to navigate to her husband John Doe's record. And she's been waiting a while for the appointment to be confirmed. So through some snooping, she just starts to play with the URLs. You'll notice that we don't see the confirm button because she's not an administrator, but what she can do is she can fire off a request to the /appointments/confirm URL. And we'll see that that invokes our controller method, and we end up printing confirmed back to the page. Now, normally there'd be some business logic there. Now, we didn't want her to be able to invoke this confirm method, and that's why we conditionally rendered the confirm button on our user interface or our JSP using the Authorize Tag. But it's not enough to prevent a malicious user from invoking this method on our service layer. So we're going to take a look at how we can provide some protection on our service layer. And it's a good practice because we're really practicing defense in depth and having security at multiple layers of our application, not just at that web tier layer. It's very important that we secure our business tier in order to prevent any attempts by malicious users to penetrate our system. So the first thing that we need to do to begin securing our service layer is we need to add some configuration. And this configuration will go in the dispatcher servlet.xml file. Now, we've been dealing a lot with the SecurityContextXML file, but in this case, we need to use our dispatcher servlet.xml file because when our web application starts, multiple application contexts will be created. And we need to have access to all of our controller beans so that we can use the different annotations that we're going to leverage to protect our method invocations on our service layer. So here we see the component scanning happening, and that's causing our controllers to be registered as beans. And then within this XML file, we're going to enable the security namespace. So I'll just click on the namespaces tab and then click on security, and that's going to insert that namespace into our configuration file, and now we can leverage it. So I'm just going to put the security, and then we use the global method security tag. And on this tag, we need to use one attribute, and that is the pre and post annotations attribute on this tag. And we want to change the value from disabled to enabled. And this will allow us to use annotations on our controllers that will allow us to require authorization to invoke these methods. So we're interested in restricting the invocations of the confirm and the complete methods. So what we'll do is we will use the pre-authorize annotation. And this is an annotation provided by Spring Security. And what it does is it requires that the user have a certain role or permission prior to invoking the method. Within the pre-authorize tag, we can specify the value element, and this can be a spell expression. So we're just going to use the has role built-in expression, and we're going to check that they have the admin role. And simply by putting that annotation in place, we have now protected that method from being invoked by a malicious user. Let's restart our server. and we'll run through our demonstration of the pre-authorized annotation. So I'm going to navigate to the browser, and we'll go back to our context root, and I think we're going to need to log out our user. We'll log out Jane Doe, and we'll log in with her husband, Joe Doe, which is actually John Doe, and a password of password. And John is also a regular user. And now we see that we do not have the option to confirm or to mark as complete because he's not an admin user. But let's say he attempts something malicious. So he's going to try to invoke that /appointments/confirm URL, which is going to hit our controller and invoke the confirm method. And now when he attempts to invoke this method, you see that we get a 403 error, access is denied. And that is our service layer protection and our pre-authorized annotation at work. And it's protecting the invocation of methods on our controller. So we have that defense in depth, and that's what we want to strive for in order to create a nice, hardened, secure application. So in this lesson, we saw how we can protect different methods on our service layer and require authorization to invoke them using the pre-authorized annotation and the global method security tag within our configuration files. In this lesson, we will take a look at another approach that Spring Security provides that allows us to protect our service layer. So we're going to take a look at how we can use the post-authorized annotation to restrict the invocation of our methods on our controllers. The post-authorized annotation is going to function very similarly to the pre-authorized annotation. It's going to allow us to specify some expression that then is used to determine whether or not we authorize the invocation of a method on our service layer. So there have been two changes made to our application in order to support this lesson. The first is we have added a method to our appointment repository, and that method's name is findByUser. It accepts an auto user argument, and it returns a list of appointments. So here we're just using Spring Data to query our database for where the appointment is equal to some user. This repository method is invoked within our appointment controller when we attempt to get all of our appointments. So instead of simply returning all appointments, we now dependency inject the authentication object into the getAppointments method, and we retrieve the principal and pass that principal into the findByUser method on the appointment repository. So let's take a look at what this does for us. I'm just going to log in as John Doe, so that's the Joe Doe user, and the password's password. And now we see when he logs in, he only gets his appointments in the appointments list, instead of also seeing the Kevin Bowersock's appointment that we have seen throughout the course. He is restricted to his own appointments, and he can drill down into that appointment and see the details. Now, let's pretend that John Doe is a slightly malicious user, and he notices our RESTful URL, and he has a hunch that's an ID. So he swaps the ID to 1, and now he can access the Kevin Bowersock's appointment and see all the details. We're going to learn how to use the post-authorized annotation and defense in depth in order to prevent this type of attack. So we'll navigate back to our appointment controller, and if we scroll down to the getAppointment method on this controller, this is the method responsible for retrieving an appointment when we click on that link within our list. So we're going to make some modifications to this method that will allow us to authorize the invocation of this method. The way we're going to do that is we're going to use the post-authorized annotation. So we'll put that in place and import it. And what's unique about the post-authorize annotation is that it is evaluated after the method is invoked. And that's the difference between pre-authorize and post-authorize. Pre-authorize is evaluated prior to the method being invoked, while post-authorize is evaluated afterwards. And that allows us to perform some unique type of logic because we can look at the returned object from the method, and we can also access some of our arguments that are passed into this method. So we need to provide an expression that should be evaluated to make the authorization decision. And we're going to grab the principal object, and we will check the auto user ID field to see if it is equal to the appointment that we are putting on our model. So we're adding the appointment we find from this repository to the model, and then that appointment has its own fields, one being the user and that having its own auto user ID. Now, the way we are allowed to access this model is by using the Spring expression language. We simply prefix the name of one of our arguments, in this case model, with a £, and then we can refer to that method argument within our expression. Remember that the model is a map, so we can grab one of the values on the map by specifying the appointment key. And then from there, we can access the user field. And on the user field, we have the auto user ID field. And that's going to allow us to ensure that the principal is requesting an appointment that belongs to them. So let's run through this demonstration. I will restart our server, and then I'm going to navigate back to our application, and I'm going to log out. Once the application logs us out, we will sign back in with John Doe. So we use the Joe Doe user and the password of password. And now we're going to navigate into his record, and we're going to attempt the attack again. And there we see access is denied, and that's exactly what we want to happen. So for our final demonstration, we're going to show how we can inspect the returned object by the method and use that return object in order to make our authorization decision. So I'm just going to change our expression to use the return object, and I'm going to check that it is equal to the string appointment. So it's fairly obvious here that this is going to evaluate to true. Normally you'd have a little bit more of a complex situation, but I'm just trying to demonstrate that we can use the return object within our expression. So I'm going to restart our server now, and then we will navigate back to our application. And once the server has restarted, we will then log in with our Joe Doe user for John Doe. So let's log out. We'll come back in as Joe Doe, password of password. And now we're going to run that same little attack over again. This time it permits it. And the reason it permits it is because very simply when it compares our return object, which is obviously appointment, to the string appointment, it evaluates to true. So you may have a little bit more complex logic there when you actually work through this example. So this concludes our lesson on the post-authorize annotation and how we can use this annotation to require authorization in order to invoke methods on our service layer. When securing our service layer, we will find that we use the Spring Security pre-authorize annotation the most. It's not very common to use the post-authorize annotation, so we'll find ourselves using this pre-authorize annotation quite frequently to require authorization to invoke the methods on our service layer. One thing to remember about the pre-authorize annotation is that it is a Spring-specific annotation, and it will couple our code to the Spring Security Framework. The good thing is, Spring developers are very aware of this fact and they do not try to lock us into the framework. In fact, they support the use of the RolesAllowed annotation, which is part of the JSR 250 package. So it is a standard annotation that can be used across different implementations of security frameworks so that we do not couple our security code to Spring. So before we begin using the RolesAllowed annotation, we just need to make sure that we have support for the JSR 250 annotations. Sometimes you need to download them via Maven in the pom.xml file, but in our case, they are included in our Pivotal TC server. So if we look, we see the annotations-api.jar, and within there is the javux.annotation, security, and then we have the RolesAllowed annotation that we will be using in our course. Now, before we go using this annotation, we need to enable its use by specifying an attribute on our global method security tag. So all we need to do is add the JSR 250 annotations attribute, and then we just switch it over to enabled. And at this point, we can use JSR 250 annotations such as RolesAllowed. So now we can navigate back to our appointment controller, and we can switch over our pre-authorized annotations to RolesAllowed annotations. Now, the big thing to remember when using RolesAllowed is that we're no longer going to use our expression language. We simply just put the authority within double quotes as the first element in the annotation, and that's going to say what role is required in order to invoke this method. Another thing to remember is that we can provide a comma-separated list of authorities. So we can say that the role_user authority is also required to invoke this method, but we're going to keep this as the admin at this point. And we'll go down and we will replace our other pre-authorized annotation. And we'll just add the RolesAllowed annotation. Make sure we have our double quotes surrounding our authority. And that's all it takes. We have now swapped out our pre-authorized annotations with our RolesAllowed annotation that is compliant with the JSR 250 standard. So if we save this, we can now restart our server. And from there, we can navigate to our browser and we'll attempt to sign in and use one of those pre-authorized annotations. So I'm going to sign in with the administrative user, kbowersox password, and then we're going to go into the appointment and we can mark it as complete. And there we see that the RolesAllowed standard annotation functioned identically to our pre-authorized annotation. So in this lesson, we learned how to use the RolesAllowed annotation, which is part of the standard Java annotations package. This annotation can be used to replace Spring Security's commonly used pre-authorized annotation in order to make authorization decisions on the methods within our beans. In this lesson, we're going to work with Spring Security's PreFilter annotation. The PreFilter annotation allows us to filter collections that are passed into our methods as arguments. So to help us out with this lesson, I have created the Appointment Utils class, which is a bean, as we can see by the component annotation. Within the Appointment Utils class, there are two methods. The first is the SaveAll method, which accepts a collection of type list with a generic type of appointment as an argument. And what we do in the body of this method is we iterate through all of the appointments and we store the email address of the user associated with the appointment into a string builder, and then we simply spit that string builder out to a string and return that from our method. The second method is just a helper method to create an appointment. So we pass in a user, we instantiate a new appointment, and then we set the user field and return the appointment. So we're getting a real bare bones appointment. So we're going to use our Appointment Utils class as a bean within our appointment controller. So I'm just going to auto wire the appointment utils bean, and I'll give it a name of util within our appointment controller class. And now we're going to construct a method that we will use to test out the PreFilter annotation. It's a little bit contrived, but the PreFilter annotation admittedly is not used very heavily according to Spring's documentation. There's kind of an edge case for the use of this annotation. So let's start building out our method. It's going to return a string, and we'll call it test PreFilter, and then we're going to pass in an authentication object as an argument to this method. And we're going to add the response body annotation. So what we return from this method will be written directly to the browser. And now we're going to add a request mapping. And we're going to map it to the appointment/test URL. And now within this method, we're going to create an auto user, and it's going to be assigned the value of our principal, which we cast to an auto user. And then we're going to create a second auto user using the auto user constructor. And then we're going to set the email address, and we'll act like this is our attacker. Then next, we'll set the auto user ID, and I'm just going to set that to 100. So we created two users. The first we just pulled from our authentication object by getting the principal. So this is our currently logged in user. And then our second user we just created. And now we're going to invoke our util using the save all method. And we're going to pass in a new collection to this method that has a type of array list with a generic type of appointment. And then I'm just going to use the double brace constructor notation in order to be able to add items into that collection. So the first thing we're going to do is we're going to use the util to create an appointment, and we'll pass in our regular user. And then we're going to use the util once again to create another appointment with the other user. So now we have a list that has two appointments within it. One that was created using our logged in user, and the other using this user that we have built within the body of our method. And they're being passed to our save all method on the appointment utils. So we're just going to save our appointment controller, and we'll run through this demonstration quick. I'm going to restart our server, and we can see what happens when we run through this scenario. So I'm going to sign in, and I'll sign in with our admin user, kbowersocks, with a password. From the appointments page, I'm just going to suffix the URL with /test. And there we see we get both email addresses. Now let's go back to our appointment utils class. And now we're going to add the PreFilter annotation. And this is going to help us filter out that collection being passed into the method. So we can use an expression, and we're going to reference the principal so we can access the currently logged in user. And we're going to check that each item within the collection that the user's auto user ID matches. So in order to reference the items in the collection, we use the filter object. And now we can access the properties on the filter object. And the filter object is pretty much always going to be the generic type. So the filter object is of type appointment. And we know the appointment has a user field on it, and the user has an auto user ID field. And we can just import the PreFilter annotation at this point. And we want to make sure that we use a capital F in PreFilter. And now we can run through our demonstration again. And this time we're going to filter out all of the items in the collection that are not owned by our logged in user. So let's just make sure we're able to run here with the server up. Okay, the server's up, and we'll hit that URL again. And now we see we only get the email address of our logged in user. And that's made possible by the PreFilter annotation which allows us to filter collections within the Spring Security framework. In this lesson, we're going to walk through an example that will demonstrate the behavior of the PostFilter annotation. The PostFilter annotation behaves very similarly to the PreFilter annotation, but there's one big difference. First, both are used for filtering a collection, but the PostFilter will filter a returned collection as opposed to an argument like PreFilter. So what are we talking about here? First, let's just go within our appointment controller and we see the getAppointments method. And when we look at this method, we see its return type is list of appointments. And we see we're using our repository to just return all of the appointments for a particular user. Now, this is very great, it's very efficient, but we're going to modify this method to, instead of filtering all of the appointments returned, to just return all of the appointments from the repository. And then we're going to use the PostFilter annotation to filter that list and whittle it down to those that are relevant or owned by our authenticated user. So first, let's just take a look at what we're going to see now. And we've actually seen this in past demonstrations. So I'm just going to sign in as kBauerSox with a password. Once our server restarts and we're in, we're going to see that we get these 2 appointments within this list. The way this page works, it invokes that method we were just looking at, and that method returns the appointments. Now we're going to add the PostFilter annotation, and this annotation accepts an expression as a value. So since we're using expressions, we can reference our currently logged in principal, and we can get the auto user ID from that principal. And then when we're referring to the items in the returned collection, we use filter object, and that expression will evaluate to each individual appointment within the list. So you know the filter object is always the type of the generic type of your collection. And knowing that we're working with an appointment, we can get the user, and the user has an auto user ID. So what will happen is when Spring Security detects this PostFilter annotation, after this method has evaluated, it will then look at the collection returned by this method, and it will evaluate this expression for each object within the collection. And that's going to determine whether or not it is then actually returned. So let's restart our server and we'll run through our example that's using PostFilter to whittle down this collection of appointments. So I'll go back and let's just navigate to our appointments URL. Let's see if it keeps us logged in here. There we go. And now we see that we just get the single appointment that corresponds with our logged in user, which is the kBauerSox user. Now let's talk a little bit about this. I wouldn't advocate for this approach. What if we had 3 million users? You want to handle that sort of work in your database by performing a query that filters down to those individual records for that user. You want to be using a where clause with a predicate as opposed to relying upon Spring Security's PostFilter annotation to do this check. But what it is good for is once you do that check where you're using a more specific query against your repository, you can then confirm that they do all in fact comply with the authorization measures that you'd like to put in place on that collection being returned. So in this lesson, we took a look at the PostFilter annotation provided by Spring Security and how it allows us to reduce the items returned in a collection of a method. In the Access Control chapter, we're going to take a look at another mechanism that Spring Security provides to secure our domain objects within our applications. So what are we talking about when we say our domain objects? Well, let's think about the application we've been building. Within our domain, we have 2 objects, an auto user and an appointment. So these are those fundamental objects that really comprise the bare bones of our application. Sometimes they'll correspond very closely with the entities that we're storing in our database and the tables within the database. In our instance, appointment corresponds exactly with our database and we store that information there, and appointment is an important domain object that makes up our system. Now, when we think about those objects, obviously we're storing that information into our database, and then we retrieve it back out at certain points, and we make instances of those objects. Well, some of those instances may belong to one user, while other instances of appointment may belong to another. So, for example, I may have a list of appointments that I have scheduled, and you may have another list that you have scheduled. Well, access control allows us to get very granular with the types of permissions that we grant to a user on those instances. So, for example, maybe you would like me to be able to view your appointments. So I have read access on every appointment that you have scheduled. Now, maybe you have access to write to those different appointments. So if you want to change something, you would need that write permission. So there we're discerning at a permission level what you have access to and what I have access to, and they can differ. In order to comprise that information, we need to construct what is known as an access control entry. And an access control entry is comprised of a principal, an object, so in this case, whatever appointment we'd be looking at, and then a permission, whether it be read, write, there's administration. So that combination of information is used to form an access control entry. And access control entries form our access control list. Within Spring Security, there are some out-of-the-box components that support ACLs. If we choose to use those components, we need to adhere to a default schema that Spring Security requires us to follow. So in this chapter, we're going to take a look at that schema, and we will set it up within our application. Once we have the schema set up, then we're going to work through and build out access control entries. Now, these are quite complex. There's roughly 4 tables, and there's some relationships between all of the tables that we'll discuss. Once we have built our access control entries, or ACEs, then we will look at the Spring Security configuration of those out-of-the-box components. This is probably one of the most in-depth configurations that you will find within Spring, let alone Spring Security. So we will walk through and discuss each of those components, and it's important to pay close attention at that point. Once we have those components in place, then we're ready to integrate the ACL features into our application. And what we'll be doing is using annotations on our controller to consult our access control list when we have to make a decision regarding a permission on a domain object instance. In this lesson, we're going to learn a more granular approach to security that focuses on the actual object level. So we are looking at a principal, an object instance, and a permission, and we're using our access control list to determine whether or not to authorize some operation on that object instance. When working with access control lists in Spring Security expects us to have a default schema that has been structured to work with the access control list features in the framework. This schema is contained within the ACL_schema.sql file, which you can find within your working files directory. At the moment, we have the H2 schema. Now, there's different flavors of this ACL schema out there. So if you are working with a different type of database, you can consult the Spring Security documentation, and within that reference documentation, you will find the appropriate SQL that fits your flavor of database. Looking at our ACL_schema.sql file, we see that there are 4 tables being created to support the ACL functions within Spring Security. And we're just going to walk down through each one of these tables and talk a little bit about them. The first table we encounter is the ACL_SID table. Now, this table is used to store information about the principals or authorities within our system. So it serves a dual purpose. You can store in some sort of role or authority, or you can store an individual principal. The first column is just an arbitrary ID, and we see we're referring to a generator within our database to create this. This second column is a Boolean to indicate whether or not this entry is for a principal or an individual user. If this were a role or an authority, we would set this to false. If this were an actual user, such as like K Bowersocks, we would set this to true. Next is the SID column, and that is the security identifier. And this is an important column because it's basically the key we're going to be using for our principals throughout the ACL table structure. In our case, we're going to be using the username of our principal, and we'll be storing that within the SID column. Next, we'll move on to the ACL class table. And this table is pretty simple. It consists of two simple columns. One is a big integer that just has basically a surrogate key within it. And then the other has this class column, which is of type varchar. And what we want to put in this column is the fully qualified class name of the objects in our system that we are going to require specific authorization to access. So in a sense, this is just storing a list of the types of objects that we want to protect using an access control list. Next, we have the ACL object identity table. This table is a little bit different and a little bit more complex. Within this table, we are storing information about the actual object instances that we're going to be protecting. So in the ACL class table, we're storing the types we want to protect, but then within the ACL object identity table, it's the actual instance of that class and that type. And we see it has a surrogate key of ID, and then the next column we see is the object ID class. And that's going to reference our ACL class table so that we know the type of the object that we are protecting via our ACL. Next, you will see the object ID identity column. And this is just the primary key of that object instance that we are protecting. So for example, within our application, we're going to be protecting the appointments, and the appointments all have an appointment ID column, which serves as their primary key and their unique identifier. So we're just going to enter that value within the object ID identity column. The parent object column is used to link to another object within the hierarchy that would be the parent for this object. The owner SID is used to establish ownership of this object. So we would be linking back to our ACL SID column using that SID we have established for our user. So for something like an appointment, it might be K Bowersocks, or we had JA Doe or Joe Doe. So we'd be pointing to those keys which we're using to identify users as defined by our ACL SID table. The final column is just the entries inheriting column, and we normally set this to true to allow for any sort of inheritance. The final table we'll use is the ACL entry table, and this table contains all of our access control entries, or ACEs for short. An ACE combines a few pieces of information to basically establish a role to access a particular object. First, we provide the SID for the principal that we are trying to determine whether or not they can access a particular object. Then we provide the object identifier within our ACL object identity. So now we're pointing at a specific object, and we know whose roles or permissions we're defining. And then we specify an order. This is just an order of precedence. And then within this, we also specify a mask, which is going to define whether they have certain permissions, such as read or write. We'll talk a little bit more about the mask when we put some values into these tables. The next three columns are normally always set to true, just so we can have some auditing and other features within the Spring Security ACL mechanism. So just remember, the ACL entry really ties everything together because we define what permissions a given user has on a particular object. So we have the object, the user, and then this mask, which is really defining their fine-grained permissions on that object. And we can also use this for groups. So our SID could actually refer to a group, a role, or an authority. So let's take this configuration and we're going to select everything. And now we're just going to move it over into our init.sql file so that it can be used by our application. And I'm actually just going to add this right before our insert statements. So just place that DDL within your file and save it. And then you can go to the project. And we're just going to run this on the server quickly to make sure that we have no SQL errors. So I'll just go to run as, run on server. We'll deploy to the server and run. And now if we go to our console, we can watch to make sure we do not receive any SQL errors. So our SQL was valid because we don't see any errors within our console. So we have set up the schema to work with access control lists in Spring Security. In this lesson, we're going to learn how to add entries into our access control list. To do this, we're going to work within the init.sql file, and we will be adding entries into our 4 ACL tables. Now, normally we would do this within our code whenever we insert a new user or we add a new domain object into our database. But we're just going to walk through this using SQL so that you can see the relationships between the different tables and learn how to build out an entry into your access control list. So the first table we'll be working with is the ACL_SID table, and this has 3 columns, an ID, a principal, and then a SID. So we'll insert values that will correspond with either principals or authorities. So let's enter our surrogate key of 1. Now we are going to be entering a user or a principal. So we will provide a Boolean value of true, and then we simply enter in the username of that principal. So in my example, here I'm using the KBauer auto user, and we can also enter in Joe Doe. So let's navigate back. We'll copy that entry, and we'll put Joe Doe within that table. And we're going to add 2 more entries, being sure to auto increment our keys each time. And our next entries for 3 and 4 are actually going to be different authorities. So we're going to set that second column to false, and then we will set the SID to role_user and role_admin. Those should look familiar to you. Now that we've finished up our work in the ACL_SID table, we're going to look at the ACL_class table. And this is a very simple table. It accepts an ID, which is a surrogate, and then the second column is a class. And that class is a varchar, and it accepts a fully qualified class name. So we're going to be protecting our appointment entity. So I'm just going to navigate to the class, copy the package, and paste in the package name, and then put in the class name of appointment. So that means we're going to be using our ACL to protect appointments. Next, we need to enter in the entries for each appointment we want to protect. So you can kind of think of this as instances of an appointment that we're going to be protecting. So you can imagine this could get rather large when working in a system. We insert that into the ACL_object_identity table. And this also accepts a surrogate ID as well as an object underscore ID underscore identity. And this corresponds with the unique key that identifies your entity or your object. And in our case, it's going to be the appointment ID. Now, there's not a relationship that's actually created, but you would want them to be consistent. Next, you provide an object underscore ID underscore class, and that's just going to point to our ACL class table to say what type the object is. We also have a parent object in case there were some type of hierarchy established. In our case, there's not. We also provide the SID of the owner. And then we have an entries inheriting column, which we will not use. It's a Boolean, but we will not need to use that because we don't have any inheritance going on. So with that in place, we can start entering values. The first thing we will provide is our surrogate, which I'll just put in 1. Now we need to provide the appointment ID. So we see this first appointment has an ID of 1, and that is our object identity. Next, we provide the type, and we just need to provide this value of 1 that corresponds with the appointment because this object is of type appointment. For the parent object, we're just going to say it's null because there is none. For the owner SID, if we look at our appointment, you will see that it corresponds with our first auto user, and that is going to be kBauersocks. So we look up kBauersocks in the ACL underscore SID table, and we add the corresponding key of 1. Next, we're going to provide a value of false for the entries underscore inheriting. And that completes our ACL object identity entry. And we're just going to duplicate that to point to our second appointment instance. So we'll increment our surrogate, and we're going to say that our object identity is now 2. And then for the type, it remains at 1. We do not have a parent, so it remains null. And then for the owner SID, we specify the second SID, which corresponds with Joe Doe. Okay, so that completes our entries into the ACL underscore object underscore identity table. And finally, to complete our entry, we're going to insert into the ACL underscore entry table. And this table really combines all of our other information, such as our object identity, our SID, and then it defines the permissions. So let's walk through our columns here. First, we have the ACL object underscore identity column, and that's going to point to an object instance. Next, we have an ACE order, and that's used if there were multiple entries for a particular object. Then we have a SID. So here you can see what we're doing. We're tying an object to a person, and then we provide a mask. And this is a bit mask that defines permissions such as read or write. So there you can see really the gist of everything. What object are we protecting, for who, and what are the permissions on that object? And that really defines an ACL. Next, we have a granting column. We have an audit success column and an audit failure column. And those normally always default to true. So let's work through this. What object do we want to protect? Well, we want to protect our first appointment, which is specified in the ACL object identity table as having a key of 1. For the order, it's 1 because it's our first role. For the SID, we are going to provide these permissions to the kBauersocks user, who has an ID of 1 in the ACL SID table. Next, we're going to provide a mask, and we haven't talked about this much, but we're just going to enter 1, which will be read-only. And then for our remaining columns, we're just going to specify true for them. That's because they normally default to that. So let's duplicate this entry, and now we're going to provide an ACL entry for our second object. So we'll change that first value to a 2 to correspond with the second object instance. We can leave the order as 1. And we're going to enter these permissions for Joe Doe, who has an ID of 2 within the ACL_SID table. And then for the mask, we'll leave it at 1 read only, and then we have our columns defaulting to true. So there we have created our ACL. And using the 4 tables, we were able to identify an instance of an object or object identity. We identified our principals using the ACL_SID table, and then we combine those 2 objects along with a set of permissions in the ACL_object_identity table to really form our access control entry that makes up our ACL. In this lesson, we will learn how to use Spring Security to configure an access control list. Now, just to warn you, this will be the most in-depth configuration that we perform throughout this course. There are many components that make up specifying an access control list within Spring Security. Luckily for us, Spring Security provides a lot of default implementations of these components out of the box. And to use those, we need to modify our pom.xml file. And specifically, we need to add 2 dependencies. The first being the Spring Security-ACL dependency. And this will contain all of those default implementations by Spring Security. And then we also need to add a caching provider. So we're going to use EHCache because that is what Spring Security integrates with right out of the box. So just select the EHCache that is from the net.sf.ehcache group. And once you have those in place, just save your pom.xml file. And now you can return to your dispatcher-servlet.xml file. So if you inspect this file, you will notice that I have already added the beans necessary in order to establish an access control list within Spring Security. The first bean we encounter is our default method security expression handler. This bean is used to evaluate permissions when a principal requests access to a particular object instance. We see that it has 2 properties that we provide. One is a permission evaluator, and the other is a permission cache optimizer. So let's talk about the permission cache optimizer. This optimizer is used to prime our cache with all of the ACL objects that we have using a single JDBC statement. So instead of looking at each permission on the fly and executing our JDBC statement to reach into our database and evaluate those permissions, we load them all up front using our ACL permission cache optimizer. The next dependency of the method security expression handler is that permission evaluator. And this works a little bit differently in that it is used to evaluate the permissions for a particular object within our access control list. We have 2 things going on here. We are optimizing and then we are actually evaluating the expressions. You see that both of these dependencies rely upon a constructor argument, which is our ACL service that is provided. And here you see that we're using a JDBC mutable ACL service. This service is responsible for translating our information within our database to the appropriate access control entries within our access control list. The JDBC mutable ACL service is the default implementation of an ACL service that Spring provides. And we can use that right out of the box, and it will work with the schema that we have already configured, that default schema that Spring Security requires us to use when using their out-of-the-box components. You'll notice that this bean accepts 3 constructor arguments, the first being our data source, which we are pulling in from our application context.xml file, the second being a lookup strategy, which we'll see in a moment, and then an ACL cache. So let's scroll down, And here we see our basic lookup strategy being declared, and that's a dependency of our JDBC mutable ACL service. The basic lookup strategy is responsible for making the database queries that are going to return the information regarding our ACLs. So you see, we kind of just keep stepping down a level in this bean hierarchy and getting further and further down closer to our implementation of what we're actually trying to do, which is retrieve all of our ACEs within our ACL and then evaluate the permissions. We see that the basic lookup strategy has 4 dependencies of its own: a data source, an ACL cache, an ACL authorization strategy, and then a console audit logger. Well, the simplest of those is the console audit logger, and this is simply going to write out information to our console when we are making decisions with our ACL. The ACL authorization strategy implementation is another bean used within our configuration, and we're not going to go too deep in this, but this is used in order to make runtime changes to our ACL or our ACE. It has a dependency of its own, which is our simple granted authority, which also has to do with the types of changes that we will be making to an ACL or an ACE. Once again, we're not going to dive into these two very heavily. What we are going to look at is our ACL cache. So here you see that we are specifying an ACL cache, and we're referring to this bean within our configuration, and it uses cache. So here we see the configuration of cache using an cache based ACL cache. And basically what this is used for is that we're going to be loading a large amount of permissions, because it is quite possible to have permissions or ACLs for as many entities that we have within our database. So as many domain objects or records we're storing for our domain objects. And we need to be able to load them, and we don't want to load them multiple times. So we put them within a cache, and that allows us to improve the performance of our system. It reduces redundant and expensive database lookups, and allowing our system to perform better. So cache, it's an open source cache that's out there. It's going to perform in-memory caching, which is going to make our lookups a lot faster. You can see that configuring access control lists within Spring Security is quite the task. This is not something you memorize. This is something you consult your working files or another resource, and then you piece these items together. Now, the final thing we need to do is we need to hook up our expression handler. Remember that all those beans we looked at, the top of that hierarchy is this expression handler. And we are just going to register that expression handler within our global method security tag. You can see that we can then, within the body of that tag, place an expression handler, and we're going to refer to that expression handler and all of its dependencies that we've declared. And at that point, we have configured Spring Security for the use of an access control list. As I mentioned, quite complex, but don't be too intimidated. There's always resources out there to help you. You have your working files to look at as well. But I would recommend going and just reading a little bit about each of these pieces to have a better understanding of them in depth. There's not too much material out there on them, but reading through the API will give you more familiarity. In this lesson, we will learn to integrate our ACL within our Spring controllers. To do this, we will have 2 different points that we will need to modify within the application in order to bring in our ACL features. The first thing that we need to do is we need to navigate to our domain object appointment. So when we are working with an ACL, we are protecting operations on domain objects. So we need to provide a mechanism to marry the domain object into the ACL system. And the way Spring Security has us do this is by returning the ID of our domain object in a method named getID. So we're just going to return along from this getID method, and it's going to point to our appointment ID. And this will help marry up our domain object appointment and Spring Security's ACL features. Next, we'll navigate to the appointment controller, and we're going to modify a method within this controller to use the has permission expression. So here we see the getAppointment method, and within this controller class, we're going to modify the getAppointment method to use the has permission expression within the post authorize annotation. So I'm just going to add the expression in, and then what we can do is we can access the model, which we're passing into our method by using the # and putting model, and then remember model's a map, and we're going to get the appointment out of the model. And that's going to be the first argument to our has permission expression, the object we want to check permissions on. And we need to make sure that we are actually using this domain object within the ACL. So we've already taken care of that with our database schema and the records we've inserted. Now we just specify a permission that we want to check that the user has access on. So here I'm checking that the user has access on the appointment and they have read access on that appointment. So let's run through this demonstration. So we'll restart our server and navigate to the app, and I'm going to sign in, and I'll just sign in as the kBowerSox user. So kBowerSox password, and we get logged in, we navigate into our appointment, and there we see we were allowed to access it. So that invoked that getAppointment method we were just working on. Now what we're going to do is we're going to require further permissions to click on one of these confirm buttons and have the operation invoked. So if we navigate back to STS, you'll see within the appointment class, we have this confirm method. And what we're going to do is modify this method to accept an appointment ID. And then we'll just pull that path variable out. So I'll have a new long, which we'll call appointment ID, and we can import that. And then what we'll do is we're going to use the repository, and we're going to find one by the appointment ID, and we will return an appointment. So it's a little bit different, but it's just a nice test here. And then we will need to go into the appointment.jsp, and from here we are going to add the appointment ID onto our confirm. So here if we look at the URL, we see that when we confirm, we are providing the appointment ID, and that's going to invoke our confirm method here. So we're going to add some different protection here instead of the RolesAllowed annotation. We're going to add post authorize once again, and then we're going to use the has permission expression, and we're going to inspect the return object this time, which is of type appointment, and we're going to check that there is administration privileges on this object. Now you're going to ask, where did I get that administration privilege? Well, if you look at the default permissions provided by Spring Security, they have read, write, create, delete, and administration. And here you see the appropriate values for them. So if you remember, when we added our entries into our ACL via the database, we added a 1 for that bit mask field that corresponded with read, a 2 would be write, a 4 would be create, and so on. And now we're just going to go in to our init.sql file, and we're going to add the administration privilege to the kBowerSox user. So here we see our ACL entry, and we see that the 4th column is a bit mask. So we're just going to copy that ACL entry, and we need to change the order. So we're saying this is our 2nd entry for that domain object. Then we move to the 4th column, and we specify a 16, which will correspond with our administration base privilege. So that's going to be required for any user that's invoking the confirm method on our controller, and we just granted that permission to the kBauerSox user. Okay, so before we restart our server, let's add in that final parenthesis, and we'll save our appointment controller.java file. And now I'm just going to restart our server, and I will open up a browser so that we can navigate to the app. And once we are at the application, you'll see that we are able to log in with the kBauerSox user. As always, kBauerSox with a password, and then we're going to go in to our appointment, and now we're going to confirm. And there we just see our appointment in JSON, and that's a signal that we were able to invoke that confirm method. So that is all provided by using Spring Security's ACL features, and we integrated them into our application by using the has permission expression and placing that on our methods so that we can require different privileges to perform operations on our different domain objects. In our final technical chapter, Advanced Features, we're going to take a look at a handful of topics within Spring Security that grant us additional options for securing our applications. One of these items is HTTPS channel security. So HTTPS is a secure protocol that we use in place of HTTP when we are transferring sensitive information from our client to our server. HTTPS will encrypt the information being passed between the two entities so that if it were intercepted, an attacker would not easily be able to discern the information being transported. Next, we'll take a look at cross-site request forgery and how Spring Security provides us with an option to protect our web applications from such an attack. We'll take a look at how CSRF can be enabled or disabled and the requirements in order to use it when creating forms within a web application. Next, we'll look at the Authentication Tag on the Spring Security JSP tag library. This tag will provide us with information about our authenticated principal and provide us with an easy mechanism to display that information on our user interface. Next, we'll move into Remember Me Authentication. Now, you're probably familiar with Remember Me Authentication, but you may not have looked at the technical details of it. So Remember Me Authentication is when you authenticate with a system on the web, and then log out and you go somewhere else for, let's say, a day, an hour, you come back, you access that web-based system, and you are automatically authenticated. Spring Security provides us with out-of-the-box support for Remember Me Authentication. It's very easy to set that up. One word of caution here. You want to be very selective to the applications that you do apply this approach to. And this is normally based upon the sensitivity of your data. So for example, if I am making a Christmas wish list, maybe Remember Me Authentication is fine. Because if somebody gets that information, really what are they going to do with it? Maybe they can have somebody buy me something that I didn't really want. There's not a lot of damage there, but if my bank is putting this in place, this would be probably not a good option for a financial institution because the information is much more valuable. An attacker cares much less about my Christmas wish list as opposed to my bank account. So you want to be selective with where you apply Remember Me Authentication. Finally, we'll move into configuring Spring Security with Java. We know that Spring has introduced Java configuration, and we'll take a look at a number of Java configurations to enable different features of Spring Security. So this chapter is really going to provide you with some additional options for securing your application. And when we put these features in place, we really get that defense in depth that makes strong and secure applications. In this lesson, we will learn how to use Spring Security to require that all traffic be conducted within HTTPS. HTTPS is a secure protocol that allows us to encrypt data that is sent between the browser and our web server. This is important when we are sending sensitive information because it prevents the information from being sent in plain text, which is vulnerable to being intercepted by an attacker. So by encrypting our data, if it were intercepted by an attacker, it would be harder for them to glean out the important or sensitive information. In order to encrypt our data, HTTPS uses two secure protocols, SSL, or Secure Sockets Layer, or TLS, Transport Layer Security. Now, TLS is the most recent secure protocol that we'll be using within this lesson. In order to create a secure session with HTTPS, we need to create a public key for our application. So we're going to use Java's key tool to create a public key which will be used to create the SSL handshake. In order to create our key, we'll need to navigate to a command prompt, and we are going to use the key tool within the JDK. So we'll issue the key tool command, and then we're going to use the gen key command within the key tool. Next, we're going to specify an alias of Tomcat, and then we need to provide a key password. So we're going to set our password to password, and then we need to specify the name of our key store, which we're going to set to keystore.jks. Next, we'll set the key store password using the store pass option, and we're going to set that also to password. Next, we need to specify the key algorithm to use, and we're simply going to use RSA, and we'll need to specify the validity, which we're going to set to 360, and finally the key size, which we'll set to 2048. Now, once we execute this command, it's going to ask us for some information. So I'm just going to provide a little bit of information here. It's going to ask you about your organization, your city. I'm just going to say USA, and I'll keep it real general here. And then finally, it's going to ask you to confirm this information and just type a yes. And then your key is going to be generated. So you can see that mine was put in C users Kevin Bowersocks, and it will have the name keystore.jks. So we're going to navigate back to STS, and the next thing we need to do is make sure our server is stopped. This is very important because we're going to change some of the configuration within our server. So once the server is stopped, we'll navigate to the Package Explorer, and we will expand the servers and our pivotal TC server, and then we're going to enter the server.xml file, and we're going to make some adjustments to this connector tag. So the first thing that we're going to do is we're going to enable SSL using the SNL enabled attribute, and we'll set that to true. Next, we need to point to our key store file, and remember mine was in C users Kevin Bowersocks, and then it was named keystore.jks. Now we're going to specify the key store password, which was equal to password. Now we need to specify our scheme, which is going to be equal to HTTPS. We need to set the secure attribute to true. We need to specify that we are not performing client-side authentication. And then finally, we need to specify our SSL protocol. And that's going to be equal to TLS version 1. So at this point, our server.xml file is configured to enable HTTPS on our TC server. Now we can navigate to our SecurityContextHolder file. Within this file, we need to make some changes to our intercept URL tag. So we're going to navigate down to these tags, and we are going to specify the requires channel attribute. And we have a few options here. If we look at the attribute, we can specify HTTP, HTTPS, or any. So in this case, we are going to specify HTTPS, and we will just copy that attribute and its value, and we're just going to add it to each one of our tags. So we're going to be requiring that all communication for our application be conducted in HTTPS, and you do see this quite frequently. So we'll now save our SecurityContext.xml file. Next, we will restart our server, and then once our server has started, we can navigate to the application, and we'll notice if we try to access the application via port 8080, we'll have issues. However, if we attempt to use HTTPS, we will then be transmitted over to port 8443, and we can access our application. So there we see we are accessing the application via HTTPS, and that was through the configuration of our Tomcat server, and then using the requires channel attribute within Spring Security on our intercept URL tags. And that attribute forces all traffic to those particular paths to a particular protocol. In this lesson, we're going to talk about how Spring Security can protect our applications from cross-site request forgery. A cross-site request forgery attack, or CSRF attack, occurs when we are logged into an application on the web and we visit another website that contains a malicious script. And that script will submit a request to the application that we are logged in as, and it will essentially rely upon our session ID in order to submit that request on our behalf. Now, normally that request does something malicious and it is disguised. Luckily for us, Spring Security provides CSRF protection right out of the box. So let's take a look at this protection in action. I am going to navigate to our application where I am currently signed in. I will then go to the appointments page and I will attempt to create an appointment. So I'll just pick a date, pick a make and a model, and then a year and a service we need. And now I'm going to turn on Firebug, and we're going to do some debugging as we submit this request. So you'll notice that if I click on Save Changes, and we look at what was passed to our server and the data that was posted, you'll see this _CRF parameter that was passed. And we get this unique combination of dashes and alphanumeric characters. That is a CRF token. And what happens is Spring Security will put the CSRF token on our page so that when it's submitted, the token can be checked to ensure it was actually a token issued by the application itself. If this were to come from some other website which is trying to submit a malicious request on our behalf, posing as us, it would not contain the CSRF token and Spring Security would complain. So this token is put on our page in a hidden input. So if we look at this div within our form, here we see that we get a hidden input with our CSRF token. Now, if we go and inspect our actual markup for the appointments.jsp page, you won't see the CSRF token being put in place. So here's that last div on our form, and you'll notice we don't see our hidden input. So where did that come from? Well, when using Spring MVC and we use the form tag, it automatically puts in a CSRF token for us. So we don't have to worry about including that token on our own. Now, if we were to use a traditional HTML form, we would then need to rely upon Spring Security's tag library to input a CSRF token. And we simply use the CSRF input tag, and we will have a CSRF token put in place within a hidden input on our rendered JSP. Now, if for some reason you wish to turn off the CSRF protection, you can do that very simply within the body of your HTTP tag. So simply use the security namespace, and then with the CSRF tag, there is a disabled attribute that you can set to true. And then you will no longer have Spring Security's protection for CSRF attacks. One thing to note about CSRF protection within Spring Security is that it is not going to apply to all requests. It mainly is looking at requests that are attempting to change or post information back. So all of your posts will need to be protected when using CSRF protection in Spring Security. In this lesson, we will take a look at the Authentication tag within the Spring Security JSP tag library. The Authentication tag grants us access to the authentication object, which is stored in the security context. The tag allows us to access that object and then display different fields on that object to our JSP file. The tag is very similar to the SecurityContextHolder in that it grants us access to some of the authentication information that we have stored within Spring Security's security context. One nice feature about the tag is that if we have stored a custom implementation of the UserDetails interface within our security context, such as the AutoUser class, which we have used, we are able to access those fields on that custom implementation of that interface. So let's run through a quick example. The first thing we're going to do is we are going to add the tag library to the top of our JSP page via a page directive. So I'm just going to use IntelliSense to pull out our security tags, and then we give it a prefix of SEC. Now within our page, I'm just going to first add a block that can only be accessed by those individuals who have been authenticated. So I'll use the Authorize tag, and then I will just use the isAuthenticated expression, and that will only allow the body of the tag to be displayed when we do have an authenticated user. Now I'm going to use our Authentication tag, and the Authentication tag has a property attribute that allows us to point to different properties on the authentication object. So I'm going to point to the principal object on the authentication object, and I'm going to display the first name. And remember that first name is coming from our auto user. And now we'll just display the last name. And let's make sure we got some white space between them. And we'll just say, welcome back. So we'll just greet our user by their first and last name. So with that change in place, let's restart our server and we'll run through our demonstration. And we'll see how the authentication tag allows us to access the different fields on the authentication object stored within our security context. So we'll sign in. I'm going to sign in as the kBowersox user with a password. And now if I navigate to the home page, there you see that I am prompted with a message that says, welcome back, Kevin Bowersox. So using the JSP tag library's authentication object, we were able to access the different fields in the data on the authentication object and easily display them to our JSP file. In this lesson, we're going to take a look at Remember Me authentication within Spring Security. Now, even if you're not familiar with Remember Me authentication, you probably have experienced it in some of the applications you work with on the web. Remember Me authentication simply allows a user to log in to our system after they have left. So for example, I log in with my credentials, I then close down the browser, I go off, do whatever I do, I come back, let's say 3 hours later, and I hit that same site, and now I am automatically authenticated. So this is accomplished using a cookie that is placed in the browser and then used for Remember Me authentication. So we're going to work through a demonstration that shows how easily this can be implemented using Spring Security. The first thing that we need to do is we need to add a checkbox to our login page that will enable Remember Me authentication. So we're going to add a new div with a class of form group. We're just doing some styling here for the most part. And then we'll add a label, and that label is going to be for our Remember checkbox. And the label will just say Remember Me. And now we're going to add the checkbox. So we'll create a new input tag of type checkbox. And then we need to specify the ID is equal to remember, so we can match up with our label tag. And then finally, we need to specify the name as remember-me. And that is a default for Spring Security. It's very important that we have the name attribute correct. You can adjust the default parameter that gets sent over when they check this box on the form. So now we have the checkbox on the form, and we need to adjust our SecurityContext.xml file in order to provide the configuration necessary to enable Remember Me authentication. So this is pretty simple. Due to the Spring Security namespace, we are able to just use the Remember Me tag, and on there is a key attribute, and this is used to identify the cookie. So we just provide any unique value here. So let's just say Remember Me, and at this point we are configured. Now let's say I wanted to adjust that parameter. You'll notice that we have the Remember Me parameter attribute we can specify, and then we can use something different than Remember Me. But we're just going to stick with our defaults. So I will save our configuration, and now I'm going to restart our server, and I'll navigate over to the application, and I'm going to sign in. So let's use the kBauerSox user with a password, and then remember to check the Remember Me checkbox, and we'll log in, and there we see we've logged in. So I'm going to copy this URL. I will close our browser, and then reopen a fresh browser. And we're just going to put that URL back in, and we're going to directly access that link. And you'll notice that I am not required to authenticate, and that's because Spring Security's Remember Me authentication kept me logged in due to that cookie that was passed to the Auto Service Center application. So in this lesson, we took a look at Spring Security's Remember Me authentication and how it allows a user to be automatically logged in when they revisit our system after previously authenticating. Throughout our course, we've been using XML to configure Spring Security. If you're familiar with Spring, you know that Java configuration is another option you have when working in the Spring framework libraries. I prefer to use XML because I believe it is more concise. People complain about tags in XML, but now we're wrapping entire configurations with method signatures. I don't see the conciseness with that approach. I also don't see a lot of supporting documentation for Java config. The body of work out there for XML is a lot greater than what is out there for Java config. So those are the things I consider when making my choice between Java and XML. With that being said, Java config is gaining popularity, and we're going to take a look at how we can perform some of our configurations using Java config within our application. So what you'll notice is that in the application, we have replaced our XML configuration with a pure Java configuration. So we have a web configuration and a web initializer class, which will set up the Java config for Spring MVC. And we're going to now add in the Java configuration for Spring Security. To set up our configuration, we will need to create two classes. So the first class that I'm going to create, we will call the Java Security Config class. And this class needs to extend a web security configure adapter. And we'll just click finish and our new class will be created. And let's talk a little bit about this class. It's going to contain all of our configuration. So we use Spring's configuration annotation in order to mark this class as a configuration class. You'll notice that it extends the Web Security Configure Adapter class. And this is a helper class that is provided by Spring that allows us to quickly set up some of our configuration. So instead of providing the explicit long approach to configuring our security, we are going to use the helper methods within that class, and they're going to provide us with a little bit more concise ways of setting up that configuration. Now that we have our configuration class in place, we need to create another class. So we're going to use the new dialog, we'll create a class, and then we are going to create a security web application initializer class. And we are going to also have this class extend a Spring provided class, the abstract security web application initializer. So let's set up that inheritance and then we'll build out our class, and let's talk a little bit about this class. So the abstract security web application initializer. This is going to act very similar to when we configure our delegating proxy filter within the web.xml file. It's going to register that filter within our Spring Security configuration, and that's going to cause the framework to handle all of the different requests. The only thing we need to do within this class is create a constructor. So I'll create a security web application initializer constructor. And then we invoke a super constructor on the abstract security web application initializer class. And we pass in our Java security config type. So there we're passing in the class file. And that's going to register that configuration when our application is starting up. So now let's return to our Java security config class. And now we'll start building out our Spring Security Java configuration. So the first piece of configuration that we need to add is Spring's Enable Web Security annotation. This annotation will allow Spring Security to integrate with the Spring MVC framework. Next, we are going to use the import resource annotation to pull in our data persistence layer. And that was configured within the webinf spring application context.xml file. So once we import that XML file, we will get all of the configuration for that Spring data setup that is performing our data persistence. Next, we are going to component scan for all of the beans within the com.o'reilly.security package. So with these 4 annotations in place, this completes our class level configuration. Now, the only annotation that is specific to Spring Security is the Enable Web Security annotation. The other 3 are specific to Spring Core's Java configuration. With the class level configuration in place, we're going to take a break, and when we come back, we'll take a look at how to provide our specific Java configuration for Spring Security. To complete this lesson, we are going to finish our Spring Security Java configuration. If you remember, we were working within the Java Security Config class, which extends the Web Security Configure adapter. Inside of this class, we are going to provide our Java configuration for Spring Security to dictate its behavior. The first thing we're going to do is we're going to start out by overriding one of the methods on Web Security Configure Adapter. So I'm just going to right-click on the class and then go to Source, and then I'm going to go to the Override and Implement Methods option, and I'm going to select the Configure method, which accepts an Authentication Manager Builder as an argument. So we'll put this method in place, and let's take a look at what's going on here. So Spring is dependency injecting an Authentication Manager builder into this method, and we can use that to set up the authentication for our application. The Authentication Manager builder just follows a builder pattern. So we're going to see how we can chain all of our method invocations. And the first thing we're going to do is we're going to use the in-memory authentication method to set up an in-memory data store to hold all of our users. So once we invoke this method, we can say with user, and we provide a username, and then we give that username's password, and then we provide roles for that user. And I'm just going to give him a role of user. So what this configuration does is it's going to protect every resource in the application. It's going to require us to authenticate when we want to access anything in the app. So let's restart our server, and then we're going to head over to the browser, and we will attempt to access the application's homepage. And when doing that, we should see that we are prompted to log in. So there are servers restarted, we provide our credentials of username and password, then we are able to log into the app. So let's log out. Now we're going to head back to our class, provide some more configuration. Now we know that in-memory data stores are not ideal. Essentially, we would like to have something a little bit more dynamic. So what we can do is we can provide JDBC authentication in this class. To do that though, we need a data source. So I'm going to create a private data source, and we'll just name it data source. And we'll use the java.sql.dataSource type. And we're going to add the auto-wired annotation so that Spring will take the data source configured within our application context.xml file and dependency inject that into this configuration class. And now we can invoke the JDBC authentication method and then set its data source using that data source that we have injected. So let's restart the app this time, and now we'll have to use the credentials for our user established within our init.sql file. If you remember, that was end-user with a password of password. So once our server has restarted, we'll be prompted with the login page. We can use end-user with the password of password, and that's coming from our database, and we're using our JDBC authentication in order to authenticate that user. Okay, next we are going to set up a UserDetailsService. So you remember that we used a UserDetailsService in order to integrate Spring Security with our custom user object of type AutoUser. So I'm just going to inject the UserDetailsService bean, which is being picked up via component scanning. And now we're going to invoke the UserDetailsService method on our Authentication Manager builder. And at this point, our UserDetailsService is in place. The final piece of Java configuration we're going to put in place is a custom form. So once again, if we right-click on our class file and go to source, we can override a method, and we want to override the configure method now that accepts an argument of type HTTP security. So within this method, we work with the HTTP security object, which is very similar to the HTTP tag we would see within our XML configuration. So we use the HTTP object to invoke the form login method. And then we need to provide our login page, and we're going to specify that as /login. So when a GET request is sent to /login, we have our controller set up to return our login.jsp page. And then once the form on that login.jsp page is submitted, we want to forward the execution to our login processing URL, which is also /login. However, what discerns between the two is the method being a GET or a POST. Next, we can set a custom username parameter. If you remember, within our form, we were using custom_username, and we can also set a custom password parameter, and that was custom_password. So with those pieces of configuration in place, we then have a custom login form set up. And we did that by overriding one of those methods on the web security configure adapter, which allows us to conveniently set up our security configuration. So with this in place, I'm going to restart our server, and then we can navigate back to our application, and we'll attempt to access the home page. And when we do, we are going to see that our custom login page will be displayed when we attempt to sign in. So here I attempt to sign in, there's our custom login page, and I can log in with our end user as we saw with JDBC Authentication. So in this lesson, we took a look at Java configuration of Spring Security. Now, one important point is that your HTTP container must be Servlet 3.0 or higher. So there are some restrictions on Java configuration, just as there would be within Spring MVC. So you need to make sure you're using a relatively new servlet container. And as you work through the configuration, you'll uncover that there are many other configurations that you can put in place, and they really do mirror the XML configuration. So once you are familiar with XML configuration, making the leap over to Java config is not very difficult. Congratulations, you have completed our course on Spring Security. Now let's take a few minutes to reflect upon what we've learned and to look ahead at some other ways to expand your skills. Within the course, one of the key takeaways is that Spring Security provides us with an easy mechanism to harden our Java web applications. We could have easily put all of these security features in place by writing customized code. However, with Spring Security, we were able to quickly put these features in place with an implementation that we can be confident in. We saw that the core of the framework revolved around two important security principles, and that's authentication and authorization. So once again, authentication, we are validating who the user is, and authorization, we are making sure they have the privileges to access the resources that they are requesting. Luckily for us, the framework provides much flexibility for these two security principles. We saw several approaches to authenticating our users and many approaches to performing that authorization component. This is one of the nice things about the framework. It really is flexible enough to fit our needs in our particular circumstances. There are a variety of approaches we can take to implementing security in our applications. Another key takeaway from this course should be how the portfolio of Spring projects work together. We saw a lot of Spring MVC being used within the course, and you'll notice how Spring Security just integrated right in with our MVC structured application. This is the case with almost all of the Spring projects. They just gel and integrate together very well, and they recycle principles so that when you learn one piece of the Spring ecosystem, you can easily translate that knowledge into other pieces of Spring. So that leads us into our next question. Where should we go next? Well, first, let me talk a little bit about how I learn. So I will go out and find good information on a specific topic or technology. You've worked through this course. Next, I need to take that information, I need to apply it. So I recommend that you go out and start a project, whether it's in the workplace or a personal project, just to get the hands-on experience with the technology and the framework, and to build your confidence working with Spring Security. Once I have done that and my confidence levels up, then I like to help others learn about that topic that I've just learned. This does a lot of things for me. It helps me learn to form my opinions on the particular topic or technology, and it reinforces the things that I have learned. So I recommend once you have mastered Spring Security, go out and teach a friend. Tell them what you've learned. Help them advance their skills. Show them the course. Help them work through the course because this is going to reinforce your knowledge. You're going to develop more expertise and you're going to learn how to articulate your knowledge about the framework. The final recommendation I have is that you go out and continue to look at the Spring ecosystem. There's a lot of great technologies out there. I think it's an exciting time. There's the time leaf templating framework, there's aspect-oriented programming, and microservices are also a huge topic right now. So there's plenty of areas if you want to continue to develop your skills within Spring. And finally, I'd just like to say thank you for investing in your career and your technical experience. It gives me the opportunity to do something I really enjoy, which is teaching other folks about technology. It really is my pleasure to walk through these courses and these lessons with you. It's something I enjoy, and I really hope that you take away from this course some good skills that are going to allow you to further your career.